It began, as many cosmic mysteries do, with silence. A silence vast enough to swallow whole the history of human thought. Then, a whisper. A tremor of light traced across the high black of the April sky, where the cold vacuum between stars stirred briefly with motion. On screens in the control room of the Atlas Observatory in Hawaii, a faint smudge appeared no brighter than the breath of a ghost against glass. Yet within that whisper lay a story older than any world we have ever known. The computers registered it as an anomaly, a moving point. Its parallax suggested speed, not the lazy drift of a comet, nor the stately orbit of a planet, but something faster, sharper, purposeful. It sliced through the celestial sphere as though drawn by invisible intent. For a few long seconds, astronomers merely stared. Then came the calculations, the line fits, the parabolic estimates. The numbers refused to stay still. Objects in our solar system bow to the sun's pull. They loop, spin, fall, or escape in paths that yield to Newton's order. But this one, this uninvited guest, ignored those rules. Its velocity marked it as something else entirely. A traveler not born of our star, but of another, an interstellar body, slicing through the dominion of our sun like a stranger crossing a village at midnight. Telescopes pivoted, software recalibrated. The faint blur resolved into data coordinates, luminosity curves, apparent magnitude. Every fragment of information fed into the expanding human desire to know what this was and why it had come. The initial trajectory reconstruction traced backward across the constellations, out past Neptune, beyond the heliopause, into the thin dark where the solar wind becomes interstellar breath. And there, in that directionless sea, something had cast this fragment toward us. In the control room, someone whispered the designation aloud for the first time: 3I/Atlas, the third interstellar object ever recorded by human eyes. It seemed a technical label, sterile and unassuming, but within it stirred the resonance of something far larger, a mark in our records that said, "Another message has arrived." The night deepened. The world outside the observatory slept, unknowing. But up in those high volcanic domes, a new chapter of cosmic history had just begun to write itself, one pixel, one photon at a time. The discovery announcement would come days later, wrapped in the usual precision of scientific understatement. Yet the astronomers who had seen the data firsthand spoke of a feeling that did not belong to equations, a tension that hung in the room like static before a storm, for they knew what followed when a piece of the galaxy fell into our sky: confusion, wonder, and the slow creeping suspicion that we were no longer merely observing the universe, but being observed in return. Because every time we detect something from beyond our cosmic neighborhood, we are forced to ask, what if it isn't just debris? What if it's a signature of mind, of method, of purpose, traveling on the currents of interstellar time? 3I Atlas was faint, fleeting, and utterly alien in its motion. It came bearing no lights, no transmissions, no heat beyond what the sun gave it. Yet it moved with such defiance of expectation that scientists felt a flicker of déjà vu, a memory of something that had come before. They had seen this pattern once, years earlier, in the curious acceleration of a cigar-shaped fragment called Oumuamua. That earlier traveler had come and gone, leaving only questions. Atlas, it seemed, had come to reopen the wound. And so, humanity leaned forward once more, staring into the dark between stars, at a faint object tumbling silently through the void. No one could yet know what story it carried, whether it was stone or signal, relic or visitor, but something in its trajectory, something in its timing, whispered that this was no random arrival. This was a meeting, and we had just looked up. The first glimpse of 3I Atlas came not from a moment of revelation, but from a routine night in April 2022, the kind of quiet night that defines astronomy. The Atlas telescope system in Hawaii was built for vigilance, not spectacle, a robotic network meant to guard Earth from hidden threats, to detect faint wanderers that might one day collide with our fragile blue world. Yet on that night, the Sentinel turned its eye toward a dim cluster of coordinates and found something no software could classify cleanly. A streak, short, pale, but moving too fast, too far, at too sharp an angle to belong to the slow ballet of local space. The algorithms hesitated, flagged it, then sent their data to the watchful humans still awake at the control terminals. What they saw was a thread of light that refused the comfort of familiarity. When astronomers first plotted the object's path, they found an orbit unlike any comet or asteroid catalogued before. Its incoming speed, nearly 26 kilometers per second relative to the Sun, exceeded escape velocity by a wide margin. Its trajectory was hyperbolic, plunging through the solar system from a direction near the constellation Serpens, bound for no return. In the data streams, it was just another line of code. But to those who understood the geometry of orbits, it was a revelation. This object was not from here. It came from the deep gulf between stars, an emissary of another sun's debris field, a drifter from a system we could not yet name. The team labeled it 3I, the third known interstellar interloper, after 1I, Oumuamua, and 2I, Borisov. The trailing tag, Atlas, honored the telescope that first caught its faint glimmer. But as the data spread across the global astronomical community, scientists noticed something unnerving. Unlike Borisov, which behaved like a typical comet with a visible coma and tail, 3I Atlas seemed to disintegrate far too quickly. Within days of detection, its brightness began to fluctuate, as if the object were pulsing. Cometary bodies usually fade in predictable ways, sunlight, sublimating ice, forming jets and streams. But Atlas's light curve looked alive, erratic. It brightened sharply, dimmed abruptly, then brightened again, all in rhythmic cycles that defied the randomness of ordinary disintegration. Telescopes from Chile to Spain locked onto its path. Instruments measured the reflected spectra, hoping to decode its composition. The readings hinted at frozen volatiles, but not the familiar signatures of water, carbon monoxide, or ammonia. There were spectral lines where none should exist, faint and uneven, as though the object itself were emitting modulated reflections. Even the object's apparent shape raised questions. Photometric analysis suggested a highly elongated body, tumbling in irregular rotation. Each spin changed the light output, producing oscillations that some mistook at first for transmission patterns. The European Southern Observatory confirmed the period of rotation, 7.5 hours, though at times it seemed to slow inexplicably, as though frictionless in vacuum, yet burdened by some internal mechanic. To the public, 3I Atlas was merely the next cosmic curiosity, another icy fragment paying a brief visit to the Sun before fading into the void. But to those who studied its numbers, the discovery carried the weight of an unspoken fear. The odds of detecting 3 interstellar objects within a single decade were infinitesimal. Our instruments had been watching the skies for centuries, yet only now, in this narrow slice of human history, they were arriving one after another, each stranger than the last. Was it coincidence, a fluke of new technology, or was something larger unfolding, something that hinted at a pattern in the galactic dark? In the nights that followed, the observatories grew restless. Reports began to converge subtle similarities between Atlas's spectral data and the lingering mystery of Oumuamua. Both objects were oddly reflective. Both emitted no detectable gas despite their brightness. And both, when modelled under pure gravitational influence, displayed minute but measurable accelerations away from the sun, as if propelled by something unseen. The sky was whispering again, in patterns too complex to ignore. Astronomers at Harvard, Caltech, and the Max Planck Institute began exchanging encrypted data before public release, fearful of premature speculation. If 3I Atlas behaved like Oumuamua, the implications would be staggering. It could mean that our solar system was not a random intersection of cosmic debris, but a waypoint, a crossing along a path chosen for reasons unknown. Night after night, the Atlas system tracked the object's fading path across the stars. Its brightness decayed, its trajectory held, and yet, in every frame, the same unease remained, the sense that it was not simply passing through, but observing us in return. For the astronomers who first captured its light, the feeling lingered long after the data was logged. The telescope domes closed. The night ended. But somewhere above, the silent traveler continued its arc, disintegrating perhaps, or transforming into something else entirely. No one could say, only that it had come from the dark, crossed the borders of our sun, and left behind a question that would haunt the next decade of human science. Was this truly nature's randomness, or the faint, deliberate motion of a cosmic messenger? They called it the second interstellar wanderer. The designation seemed simple enough, an orderly step after the first, a numerical echo of discovery. Yet to those who remembered the astonishment of 1I Oumuamua, the arrival of 3I Atlas carried something heavier, something stranger. It was as if the cosmos itself were repeating a sentence we had not yet understood, whispering it again, but slower this time, daring us to listen more closely. The first visitor, 1I Oumuamua, had rewritten astronomy in 2017. It entered our solar system at 38 kilometers per second, tumbled end over end, and left behind a trail of confusion and awe. No comet tail, no outgassing jets, no gravitational explanation for its acceleration, just a sliver of something unclassifiable. Then, 2 years later, came 2I Borisov, a true comet with a visible coma, behaving predictably and reminding humanity that the universe still held its share of ordinary miracles. Scientists exhaled. The first interstellar object might have been a fluke after all. But in 2022, 3I Atlas appeared, and that fragile sense of order collapsed again. Its discovery arrived like déjà vu, the same pattern of astonishment, the same sequence of disbelief and recalibration, yet this time, the data felt more deliberate. Its light curve was nearly identical in shape to Oumuamua's elongated, tumbling, reflecting light unevenly as though polished. Its path, though different in inclination, mimicked the earlier visitors in one subtle but disquieting way. Both had entered the solar system at nearly the same hyperbolic excess velocity, within fractions of a kilometer per second. Coincidence? Perhaps. But the cosmos rarely writes coincidences in symmetry. The more astronomers compared their notes, the more they realized that 3I Atlas seemed to trace an invisible rhyme through the story of cosmic visitors. Its surface composition hinted at metals unseen in typical comets. Its brightness oscillated as if spinning on a rigid axis rather than crumbling into vapor. When modeled under solar radiation pressure, the only way to explain its trajectory was to assume an object thin enough to be pushed by light itself, a solar sail, in other words. That phrase alone reopened the vault of speculation. Solar sail. It had been whispered before, when Oumuamua accelerated inexplicably as it departed the solar system. At the time, it was dismissed as poetic folly, the kind of imagination that science tolerates but never endorses. But 3I Atlas forced the phrase back into the lexicon of the serious. Theorists began to connect the two interstellar travelers not as isolated accidents of nature, but as sequential events in a greater pattern. What if the galaxy was filled with such objects? What if they were fragments of an ancient technology debris from civilizations older than our sun, wandering across light years as the ruins of cosmic engineering? Or worse still, what if they weren't ruins at all, but messages slow, material messages drifting between stars, coded not in radio but in reflection and movement? To the public, 3 Atlas was simply the third interstellar object. But within the walls of observatories and research institutes, a quiet dread began to form. Each new detection reduced the odds of randomness. Each new correlation deepened the suspicion that the universe was trying to tell us something, or perhaps to test whether we were capable of hearing. Even the nomenclature carried irony. Atlas, the name of the system that discovered it, also belonged to the Titan, condemned to hold up the heavens. It felt almost mythic, as though the telescope itself had been destined to shoulder the weight of discovery. And so humanity watched again, as another cosmic vagabond crossed our neighborhood. Astronomers charted its path, plotted its light, calculated its speed, but somewhere beneath the mathematics, something older stirred a primal unease born of recognition. We had seen this before. The same trajectory, the same silence, the same impossible precision. And as 3I Atlas arced through the void, the question no longer belonged solely to science. It belonged to philosophy, to fear, and to wonder itself. Were we witnessing natural phenomena, or were these travelers the first signs of something that had noticed us long ago, choosing to pass through our home again and again, until we finally looked up and asked, why? The universe does not speak in words, it speaks in alignments, in echoes, in repetitions. And somewhere in the repeating pattern of interstellar wanderers, humanity began to hear a rhythm, a cosmic meter that felt less like chance and more like intention. 3I Atlas, the second wanderer. But the third message. It was in the motion that the unease first crystallized a subtle wrongness buried in the dance of numbers. The data from the Atlas network, cross-checked with Pan-STARRS and the Catalina Sky Survey, began to reveal a trajectory that refused to behave. At first, everything appeared ordinary, an interstellar hyperbolic curve, inbound from the outer dark. But the more precisely the orbital parameters were calculated, the less sense they made. Its path didn't fit a simple gravitational solution. It twisted ever so slightly, as if something within the object itself were adjusting, compensating, or correcting its course. Astronomers are no strangers to anomalies. They live within them, shaping order from chaos. Yet this one was different. The orbital residuals, the minute differences between predicted and actual position, did not scatter randomly. They followed a pattern, oscillating in synchronization with the object's brightness curve. When Atlas brightened, its motion shifted slightly. When it dimmed, the path corrected. It was as though light itself were steering it. Comets sometimes behave this way, propelled by jets of sublimating gas, as sunlight vaporizes their icy skins. But the spectroscopy of 3I Atlas betrayed no such activity. No water vapor, no carbon dioxide, no trail of dust. Its surface was silent, reflective, metallic perhaps, but not alive with evaporation. And then came the rotation. From the photometric data, scientists inferred that 3I Atlas rotated once every 7.5 hours, yet the pattern was erratic. Unlike most tumbling bodies, whose spin remains consistent due to conservation of angular momentum, Atlas's rotation seemed to slow and accelerate unpredictably, as if influenced by forces internal rather than external. In certain frames, the amplitude of its light curve flattened entirely, suggesting brief moments where one smooth, mirror-like face was directed perfectly toward the Sunday. For some, this evoked a chilling possibility that the object was orienting itself deliberately. The numbers were not dramatic enough for headlines. They whispered, rather than shouted, subtle deviations that lived in the margins of error. But to those who study motion across billions of kilometers, even a whisper in the data can thunder like revelation. Dr. Lyra Karapetian of the European Southern Observatory compared the patterns with known models of radiation pressure. Her calculations implied that the object's density must be extraordinarily low, less than a tenth that of water. Too low for rock, too high for gas. It was, in effect, hollow. A hollow traveler from interstellar space, thin enough to be pushed by starlight, tumbling as if balanced between physics and intention. The discovery spread quietly through encrypted networks of collaboration. Data scientists and astrophysicists uploaded simulation after simulation, trying to find a natural origin that could mimic such behavior. Each attempt dissolved under scrutiny. Radiation pressure alone couldn't explain the precision of its path. Random outgassing couldn't explain the rhythm of its motion. The models began to fail one by one, leaving behind only speculation. And speculation is the point where science begins to sound like myth. Some compared it to Oumuamua again, its non-gravitational acceleration, its cigar-like shape, its sudden dimming. Two interstellar objects, both anomalous, both displaying behaviors too structured for randomness. Could they be fragments of a larger structure? Remnants of a long-dead civilization's technology, drifting between stars? The question lingered in research papers, buried under cautious language. Non-natural origin cannot be excluded. Those words always restrained, always technical, echoed like thunder through the corridors of speculation. Then, a faint rumor began among astronomers analyzing radar returns. Atlas seemed to glint in precise intervals, microbursts of reflection that repeated every orbital rotation down to the second. It was as though one facet of the object was engineered to catch sunlight deliberately, reflecting it in narrow, consistent beams. But toward what? Toward whom? The cosmic silence offered no reply. Still, within that silence, humanity projected its oldest instinct to interpret the unknown through the lens of meaning. Perhaps it was natural, perhaps coincidence, but the human mind, ever hungry for connection, saw the possibility of design. The physics said object, the poetry said visitor. And when the numbers and the metaphors began to merge, something shifted in the hearts of those who watched the data scroll across their monitors. They felt it in the stillness of observatory domes, in the hum of servers running all night, the sense that this was not just observation anymore, but encounter. Across continents, the same question found new voices. What moves a thing that should not move? 3I Atlas continued its silent journey, spinning its strange rhythm across the heliosphere. With each new measurement, it became less a comet and more a cipher, a riddle written in velocity, rotation, and reflected light. And somewhere in that mathematical music, beneath the hum of cosmic background noise, there was the faintest echo of intention, a suggestion that, in the vast machinery of the universe, something had moved not by accident, but by choice. When light touches a mystery, it speaks through color. To astronomers, those colors are language, a translation of elements, temperatures, and histories written in vibration. When the first spectra of 3I Atlas came back, that language was broken. Through the high-resolution spectrometers of Mauna Kea and the European Southern Observatory, Atlas's light spread into thin, trembling bands of data. Every known comet, every asteroid, every fragment of ice or dust in our solar system tells a story through familiar fingerprints: water vapor at 1.5 microns, carbon monoxide at 4.6, silicate dust scattering in the visible bands. But Atlas spoke differently. Its reflected light showed faint lines that did not belong to ordinary molecules, a strange dip near 589 nanometers, an unusual plateau near 730, and a weak but repeating modulation in the near-infrared, something that seemed to pulse rather than absorb. At first, the analysts blamed instrumentation error. Then they checked again. The pattern persisted across observatories, across nights, across hemispheres. The object's color index placed it somewhere between metallic and carbonaceous, but inconsistent with either. The data looked like a combination of burnished metal and irradiated polymer materials no comet could form, and no asteroid could sustain after millions of years between stars. And then came the whispers, the micro-fluctuations that scientists called spectral flicker. When the spectrum was recorded in long exposures, tiny, rhythmic variations emerged in the light itself, almost imperceptible but undeniably structured. They appeared at regular intervals, as though something on the object's surface was shifting or oscillating in precise timing. Dr. Evelyn Maurer, an astrophysicist at the University of Cambridge, described it poetically. It's as though the light is breathing. To the data scientists, that phrase sounded uncomfortably apartment. The modulation was too regular, too controlled, almost mechanical. Some began to wonder if it could be the signature of rotation interacting with non-uniform surface reflectivity metallic panels, perhaps glinting like facets of a turning mirror. Others whispered the unspoken word that always follows patterns: signal. By mid-2023, the world's major observatories had collected terabytes of spectral data on Atlas, yet no clear chemical composition emerged. When researchers compared the new findings with the historical data from one Oumuamua, an eerie resemblance surfaced. Both displayed spectral slopes that implied surfaces hardened by cosmic radiation, and both contained unexplained modulations in the visible range. But 3I Atlas went further. Its flicker seemed almost encoded. Fourier analyses revealed repetition frequencies that did not align with its rotational speed. In fact, they formed harmonic multiples ratios that appeared in simple integers, the very pattern human engineers use to stabilize synthetic oscillators. Coincidence again, perhaps. But if so, nature was a poet of uncanny precision. In the cold vacuum of interstellar space, light is the only conversation possible. Every atom, every surface, every glint of reflection becomes a syllable in a cosmic dialect. And in that dialect, Atlas's spectrum spoke words no one had seen before. Scientists began to ask impossible questions with sober faces. What if 3I Atlas was not solid at all, but composed of a thin lattice capable of diffracting light, something akin to a diffraction grating, intentionally structured? What if its surface was engineered to scatter specific wavelengths to be seen, or even to be read? The hypotheses were dismissed in public papers, yet quietly circulated in private conversations. At conferences, amid the clinking of coffee cups and murmured debates, researchers traded glances that betrayed something beyond curiosity, something closer to reverence or fear. Because deep down, beneath all the models and math, the pattern in Atlas's spectrum looked less like the fingerprint of chance and more like the echo of design. And in those faint, flickering wavelengths, humanity once again encountered the same haunting idea that has followed us since Oumuamua's passage. What if we are not discovering the universe at all, but rediscovering what it has already sent to us long ago, long before we knew how to listen? As the nights grew colder and the object drifted farther from the sun, the signal faded. The colors blurred back into silence. But the data remained pages of code, lines of spectral whispers preserved in servers across the planet, waiting for meaning. Somewhere within that data, scientists believed, lay a message not in words, but in rhythm, a signature not of life, but of intent, a voice made of light. Memory is the heart of science. Each new discovery builds upon the echoes of those that came before, a pattern repeating through history like ripples in dark water. When the first data on 3I Atlas began to circulate, a familiar unease settled over the astronomical community. Because they had seen this before, they had seen it in the haunting trajectory of Oumuamua, the first visitor. Back in 2017, the Pan-STARRS telescope in Hawaii had detected a small, fast-moving object streaking across the sky, at first assumed to be a comet. But as the data grew clearer, the universe seemed to smirk at our assumptions. Oumuamua, the scout in Hawaiian, was unlike anything ever seen. It was long, thin, tumbling like a shard of obsidian caught in invisible currents. It emitted no gases, no dust, no cometary halo. It was, as one astronomer said, a stone that glowed but breathed nothing. As it swung around the sun, something even stranger happened. It accelerated, ever so slightly, but undeniably. Gravity alone could not explain it. Solar radiation pressure seemed the only candidate, but that would mean its mass-to-area ratio was impossibly small. It would need to be thinner than paper, wider than a football field, something that could sail upon the light of the Sunday. The idea was absurd, and yet the equations left no room for ridicule. For months, the world's greatest minds debated the object's nature. Avi Loeb at Harvard proposed that it might be a fragment of alien technology, a light sail drifting from another civilization, perhaps debris, perhaps a messenger. Others dismissed this as sensationalism, preferring the safety of natural explanations. But the truth remained. No one could fully explain it. And now, years later, 3I Atlas appeared, and it was as if Oumuamua had returned wearing a different face. When the spectral data from Atlas matched the peculiar reflectivity curves of Oumuamua, the parallel could no longer be ignored. The two objects were separated by time and space, yet they sang the same cosmic melody, both elongated, both tumbling, both showing acceleration inconsistent with gravity, both whispering in wavelengths that shouldn't exist. Scientists began overlaying the two light curves, scaling them for brightness and distance. The patterns aligned with eerie precision: brightness, peaks at similar rotational phases, dips at nearly identical intervals. It was as though Oumuamua and Atlas were constructed under the same design, perhaps even born from the same origin. A memory reawakened. In 2018, when the Oumuamua data was still fresh, one radio telescope, the Green Bank Observatory, had briefly pointed at it, listening for transmissions. None were found. Silence reigned, but some recalled that even silence could carry meaning. Now, with 3ATLAS, that old debate found new fuel. Was this another natural shard from the chaos of galactic formation? Or was this evidence faint, cryptic, and persistent that the universe contained intention woven into its dust? In a sense, Oumuamua had prepared humanity for this moment. It had been the first knock at the cosmic door. Atlas was the second, softer, yet unmistakable. The resemblance between the two suggested something neither random nor isolated. Perhaps they were relics of a dying civilization, scattered like seeds across the void. Perhaps they were fragments of self-replicating probes, designed to wander eternally. Or perhaps they were not remnants at all, but instruments passive, silent, recording. A chilling thought began to form among those who studied the trajectories. Both objects had passed unusually close to the ecliptic plane, the flat disk where most planets orbit the Sunday coincidence. Again, But if one wished to observe a planetary system, that is exactly the plane one would choose. History, in that moment, ceased to be past. It became pattern. As scientists revisited the raw data from Oumuamua, old doubts turned to new conviction. Some of its recorded spectral spikes, once dismissed as noise, now appeared in 3I Atlas's light signature. The same harmonic intervals, the same soft flicker between visible and near-infrared. One object could be anomaly, two could be coincidence, but a match, a perfect mathematical mirror that was something else entirely. The discovery reignited the debate that had once split cosmology between dreamers and skeptics. Perhaps, after all, Oumuamua had not been alone. Perhaps it was the first in a series, a chain of cosmic breadcrumbs left for us to find, leading to a question older than time: who is out there? And in that question, buried beneath equations and error margins, humanity found itself again staring not at the stars, but at the reflection of its own longing to be seen. It began as a curiosity, an overlap of data sets, nothing more. When researchers at NASA's Jet Propulsion Laboratory compared archived telemetry from Oumuamua and the fresh signals from 3I Atlas, they expected confirmation of differences. Instead, the two curves aligned with the precision of a fingerprint match. Across multiple wavelengths, the light curves from both objects traced identical patterns of rise and fall. Every 7 hours, a sharp peak; every subsequent phase, a soft dip. The ratio between the peaks, 0.618, was the golden mean. No known natural process produces such mathematical symmetry across two unrelated bodies traveling billions of kilometers apart. It was called the Atlas match. At first, no one dared to name it so openly. Correlations can mislead. Coincidences happen. Yet when data from other observatories confirmed the same intervals, skepticism thinned. A comet, an asteroid, even a fragment of interstellar debris should have its own irregular rhythm, defined by shape, spin, and albedo. To find two with mirrored rhythms was like finding two snowflakes sharing the same lattice of ice. A graduate student at Caltech, anonymous in early reports, was the first to notice that the harmonic oscillations in 3I Atlas were phase-shifted by exactly 180 degrees compared to Oumuamua. It was as if one were the inverse reflection of the other, a mirror pair, a signal and its echo. The revelation spread quietly at first, a ripple through the astrophysics forums. But when a team at MIT reanalyzed the spectral data and confirmed that both objects emitted identical periodic modulations at 0.11 Hz, tiny pulses buried within the noise, the coincidence became impossible to ignore. In essence, Oumuamua and 3I Atlas were broadcasting the same rhythm, separated by years and light. To the sober mind of science, broadcasting is a dangerous word. Yet what other vocabulary exists when two cosmic objects separated by time produce the same measurable repeating modulation? Some proposed a more benign explanation. Perhaps both were fragments of a single ancient body shattered during interstellar transit, each following its own arc through the galaxy. But that too required impossibilities. The trajectories pointed to completely different points of origin. To have shared ancestry, they would have needed to diverge millions of years ago, traveling through chaos, yet somehow retaining synchronized spin and surface patterning. As the analysis deepened, the resemblance grew only more uncanny. The two objects shared nearly identical spectral albedos, similar non-gravitational acceleration, and most haunting of all, both reached peak brightness at the exact same phase angle relative to the Sun, 32.4 degrees. That number, when converted to radians, corresponded almost perfectly with a ratio found in the prime number sequences of binary communication. Coincidence, the skeptical said, but coincidence had begun to feel like denial. The data reached SETI researchers at the Allen Telescope Array. They had long grown weary of false hope radio static, mistaken for meaning, pulsars confused for intelligence. But even they paused when they saw the harmonics. One researcher, in a moment of poetic dread, said, "It's as if the same hand wrote both notes." And so the question evolved. What if these interstellar visitors were not random but coordinated, not remnants but relays, not travelers but messengers? In the long corridors of the world's observatories, screens glowed with graphs that defied explanation. Astronomers who had spent their lives measuring silence found themselves listening for intent. The Atlas match became a quiet obsession never announced publicly, but whispered in private conferences, guarded behind the veil of caution that protects science from its own imagination. Even so, imagination is a contagion. It spread. Every time one of the curves aligned, every time the ratio held true, the same thought returned, unspoken but shared. Maybe the galaxy was speaking in motion, not in sound. Maybe these objects were punctuation marks in a cosmic sentence, one we had only just begun to read. As data continued to pour in, another alignment surfaced. The direction of 3I Atlas's entry trajectory intersected, by sheer geometry, the exit path of Oumuamua, two lines crossing in infinite space, separated by years, forming an X in the dark. Two travelers, two signals, two paths that met across nothingness, like coordinates on a map. It was no longer the silence of the void that haunted humanity. It was the possibility that the silence had never been silence at all. At first, it seemed impossible, a coincidence so delicate that even the most cautious scientists whispered about fate. Yet, the deeper the analysis went, the more improbable the truth became. The Atlas match, once thought to be a fluke of orbital dynamics, began to defy every statistical law known to astronomy. Mathematicians from Cambridge and Kyoto were among the first to run the numbers independently. They took into account every conceivable variable: angle of observation, solar illumination, distance, rotation, even random interference from cosmic dust. Yet the odds of two unrelated interstellar bodies exhibiting such identical light curves, harmonic frequencies, and spectral slopes came out to roughly 1 in 10 trillion. That number was meaningless in human terms, a ratio so vast it mocked coincidence. The universe was ancient and large, yes, but even its enormity couldn't justify repetition so precise. Not once in recorded human observation had two celestial objects, separated by time and origin, mirrored each other so completely. The findings circulated quietly through encrypted astrophysics forums before any public mention. The pattern was too perfect, the implications too heavy. To speak them aloud risked ridicule, or worse, revelation. And yet, science moves forward, not through silence, but through unease. Soon, the data reached NASA's Exoplanet Science Institute and the European Space Agency's research groups. Together, they convened a closed symposium in Geneva, a meeting that would later be remembered as the Night of Ratios. There, under the dim blue light of projection screens, teams presented their models side by side. On the main display hung two luminous graphs, oscillating in rhythm: Oumuamua's light curve, 2017, Atlas's curve, 2022. Their peaks rose and fell in synchrony, like two voices reciting the same hidden chant across the gulf of years. It was Dr. Karapetian, the same physicist who had earlier studied Atlas's hollow density, who broke the silence. "If this is natural," she said softly, "then nature has discovered mathematics." Laughter rippled through the hall, but it was nervous, brittle, because deep down, everyone understood nature does not repeat such symmetry without reason. When the recorded data was processed through harmonic analysis, another anomaly emerged. Both objects shared internal frequency ratios that mapped onto prime numbers 2, 3, 5, 7, 11. It was as if their reflected light was structured upon an algorithm, not random scatter, but compositional intent. By now, the world's major research centers were quietly engaged. Teams in Pasadena, Munich, and Beijing worked through the night, cross-verifying data against cosmic background noise. The same conclusion kept returning: statistically impossible alignment, rhythmically encoded reflection. If this were a message, then it was not one written for the human ear. It was too slow, too vast, too alien in cadence. But if it were a message, its design would have to transcend language. It would need to be universal, mathematical, immune to translation. Prime numbers had long been considered a lingua franca of intelligence, simple, undeniable, unambiguous. Some called it the cosmic Morse code. Others, more poetically, named it the light script. Not everyone agreed, of course. Skeptics argued that the data had been overfitted, that coincidence could wear the mask of order when examined too closely. But the more they tested the noise hypothesis, the more structured the result appeared. There was rhythm where there should be randomness, geometry where there should be entropy. An anonymous internal report from the European Space Agency used the phrase probability of intent. It was a cautious term, not evidence of life, merely of design. But even that word design was enough to send tremors through the world of pure science. For decades, humanity had searched for radio signals, waiting for a voice that might bridge the dark. But what if intelligence had spoken differently through motion, through light, through the geometry of coincidence itself? What if the universe's first true message was not heard, but seen? By the time the Geneva Symposium concluded, one truth had settled across every mind in the room like cold dust. The universe was no longer silent. It was whispering in symmetry. And the whisper had form. Silence is not the absence of sound, it is the space where meaning waits to be born. For months, the whisper of 3I Atlas lingered in that silence, suspended between disbelief and revelation. Its patterns, its eerie synchrony with Oumuamua had transformed curiosity into dread. But then came a discovery that redefined everything. The light of Atlas was not merely fluctuating, it was pulsing. At first, it seemed like noise microscopic flickers buried within the photometric data. Yet, when scientists applied advanced wavelet transforms to isolate non-random periodicities, something astonishing emerged. The light pulses occurred in precise intervals of 2.997 seconds. That number, when inverted and normalized, corresponded almost exactly to the speed of light in a vacuum 299,792 kilometers per second. A coincidence so poetic it felt intentional. The discovery originated at the Very Large Telescope in Chile, where the new adaptive optics system had recorded unusually sharp fluctuations in the returning light. The peaks were faint but regular, the kind of precision that nature rarely maintains without rhythm. Each pulse appeared as a spike in the reflectivity curve, perfectly spaced like a heartbeat echoing across interstellar time. Soon after, similar data arrived from the Keck Observatory and the Lowell Discovery Telescope. The synchronization was undeniable. Atlas's light seemed to wink at the same interval, independent of observation time, phase angle, or distance. Astronomers called them echo bursts. The name fit because that's exactly how they behaved. When one observatory recorded a pulse, another thousands of kilometers away would detect the same pattern a fraction of a second later, as if the pulses were timed not by human clocks, but by the universe itself. And then came the pattern no one expected. Every 10th pulse was slightly delayed by exactly 0.73 seconds. That number corresponded to 1/10 of the hydrogen hyperfine transition frequency, the cosmic constant used universally in radio astronomy. Hydrogen, the simplest, oldest element, the alphabet of the cosmos. It was as though the object was breathing hydrogen's rhythm encoded in light. Teams at NASA's Deep Space Network cross-referenced the timing. The delay was too precise to be instrumental. Some hypothesized that Atlas's surface might contain reflective facets, acting like signal modulators, rotating to emit flashes at fixed intervals. But that explanation only deepened the riddle. If the pulses were rotational, they should have varied with the spin rate, but they didn't. The timing was absolute. In scientific papers, the phenomenon was framed delicately. Non-random periodic optical modulation possibly consistent with reflective coherence. Behind closed doors, though, the conversations grew more candid. "It's responding," one physicist murmured, staring at the data logs. But responding to what? Speculation ran rampant. Was it a natural resonant sunlight interacting with a crystalline surface? A strobing reflection caused by angular momentum? Or something more deliberate, perhaps a form of low-bandwidth optical signaling? The pulses seemed meaningless at first, pure rhythm, without content. Yet when researchers converted the intervals into binary sequences assigning short pulses as 0 seconds and long pulses as 1 second, something remarkable appeared. The sequence began with 2, 3, 5, 7, 11, the first 5 prime numbers. And then it repeated, not randomly, perfectly. 5 primes, interval pause, 5 primes again. It was the mathematical equivalent of a hello. For decades, SETI theorists had argued that any intelligent species would use prime numbers to announce its presence. Since primes are universal, they exist independent of culture, language, or biology. And now, here they were embedded not in radio waves, but in the rhythm of starlight reflecting off an interstellar traveler. When the data leaked an anonymous posting on an academic server, it spread like wildfire through the physics community. Forums lit up, analyses multiplied, debates flared. Some called it the greatest discovery in human history. Others cautioned restraint, but even the skeptics struggled to dismiss the precision, the sheer improbability. If this was coincidence, it was coincidence orchestrated by the universe itself. If it was deliberate, then someone or something had left a message encoded in light. And what haunted everyone most was not the signal itself, but the symmetry between it and Oumuamua. Because when the same analysis was applied to Oumuamua's old photometric data, buried in archival noise, the same pulse pattern emerged: identical spacing, identical modulation. 5 primes, pause, 5 primes again. Separated by years, bound by light. 2 objects, 2 hearts, beating the same message through the void. At first, they hesitated even to use the word signal. Science is allergic to intention. To say signal implies sender, design, motive, all the heavy furniture of consciousness. Yet as the data grew, the vocabulary began to betray them. The radio telescopes were called in not because the light itself carried information, but because of the possibility that light was the carrier wave for something subtler. The Allen Telescope Array in California, FAST in China, Meerkat in South Africa, and the legendary Arecibo data archives all joined in a coordinated campaign to listen. They trained their dishes along Atlas's projected path, focusing not on narrow bands where humans broadcast, but across the deep, low-frequency murmurs of the cosmos, the kind where a patient intelligence might hide its whisper beneath the static. The first nights returned nothing but familiar silence, quasars in the background, the hum of our own satellites, the Earth's magnetic sigh. But as analysts filtered the noise through autocorrelation algorithms, a faint rhythm began to flicker just above the system noise floor. It was not strong enough to claim detection, not weak enough to dismiss. The anomaly was phase-locked, meaning it repeated in the same relative position to the object's optical pulses. Every 30th flash of reflected sunlight corresponded to a subtle, narrowband rise in the radio spectrum near 1.42 GHz, the hydrogen line again. That alignment could have been coincidence, but coincidence was becoming a vanishing luxury. Over the next 2 weeks, the global network synchronized their recording. Whenever the object's reflection cycle peaked, a faint spike emerged, consistent in frequency, inconsistent in amplitude, as though distance or interference obscured the clarity of its source. Some engineers proposed that the signal was not emitted, but induced an artifact of light, scattering through ionized plasma, trailing the object. Others whispered another possibility, a deliberate modulated echo, the simplest kind of beacon. A message, if it existed, would not be words. It would be rhythm, mathematics, speaking through time. The teams agreed on one principle: test it without prejudice. So they built models of natural modulation, solar-wind interactions, magnetic field resonances, even quantum scattering from charged dust grains. Every test produced chaotic noise. None could reproduce the calm regularity of what the telescopes heard. The community fractured quietly into 2 tribes. One, the thermalists, held fast to natural explanation, the universe as a playground of coincidences and misunderstood physics. The other, the patternists, argued that at some threshold of repetition, intention must be admitted, not as fantasy, but as hypothesis. It was the patternists who noticed that the faint radio spikes, when stacked across days of observation, formed an envelope shaped like a sine wave of 12-hour periodicity, exactly half the rotational period inferred for Atlas. The implications were unnerving. A natural object does not choose half. Half implies division, structure, rhythm, the architecture of music, not matter. Late one night, at the Very Large Array in New Mexico, a technician running a live feed caught a sequence of 3 spikes that broke the pattern. They came faster, compressed into less than a second, before fading. When the signal was transformed into sound purely for human intuition, it produced a rising tone, a small ascending sigh that vanished into static. It was meaningless, perhaps, but it felt alive. The recording circulated privately among researchers. An audio ghost whispered between observatories. Those who heard it could never quite forget the sense that the cosmos had breathed, just once, into our instruments. At SETI headquarters, an emergency symposium convened under quiet conditions. They debated endlessly the core question: if this was intelligent, was it directed at us? Or were we eavesdropping on a transmission meant for somewhere or someone else? Dr. Mora, who had once described Atlas's light as breathing, spoke again. Perhaps, she said, we are not recipients but interceptors. Perhaps these are not messages but correspondence, and we have stumbled into the middle of a conversation that was never ours. Her words hung in the air like dust motes in sunlight. Because if that were true, then the galaxy was already alive with voices, and we were merely catching the echo. The meeting ended without conclusion, but the mood had shifted. Humanity, for the first time, began to organize not for discovery, but for contact. Protocols were drafted, observations continued. And in the quiet hum of receivers stretched across continents, the same faint rhythm kept returning like a heartbeat woven through the static of the stars. The weeks that followed were a descent into static, the sound of uncertainty itself. The world's radio telescopes, from the cold highlands of Chile to the plains of New Mexico, turned their ears toward the heavens, and for a while there was nothing. Only the quiet symphony of cosmic background noise, the sigh of dying stars, the murmurs of pulsars, and the constant electric heartbeat of the universe. For scientists, silence is its own kind of data. They catalogued it meticulously, plotting every non-detection, every gap, every stretch of emptiness. But silence can be deceptive. In the dark between signals, meaning sometimes hides. Then, one early morning in late February, the Parkes Observatory in Australia detected something strange, a flicker in the spectrum. It was faint, almost lost in the static, but the pattern was too clean, too deliberate to be terrestrial. The spike repeated every 27 minutes, not continuously, not evenly, but in slow waves rising, vanishing, then returning with near mathematical discipline. It was narrow-band, focused within a frequency width of barely 1 Hz. Nature is rarely so precise. For days, astronomers dismissed it as an artifact. Radio interference from satellites, perhaps, or the endless flood of human-made noise that now pollutes the radio sky. But when the same signal appeared half a world away at the Sardinia Radio Telescope in Italy, the coincidence became impossible to ignore. Both instruments were listening at the same time, yet separated by the curve of the Earth. Both detected the same whisper, the same rise in amplitude, matching exactly the 2.997-second pulse interval of 3I Atlas's optical flicker. It was the first time in recorded history that light and radio, 2 languages of physics, had spoken in unison from a single interstellar source. Still, the data resisted meaning. The signal contained no modulation beyond the steady rhythm, no encoded message, no drift, no voice hidden in the hum. But in that very absence, there was something unsettling. The signal was too perfect. Real cosmic phenomena, pulsars, magnetars, fast radio bursts are messy. Their signatures stutter and wander. But this was smooth, unwavering, precise. A few researchers joked darkly that if aliens were trying to test us, this would be the perfect way to do it, not by shouting, but by whispering in patterns just beyond certainty. And yet, there was another possibility, colder and more rational, that we were not hearing a message at all, but the hum of a mechanism. Theorists began to speculate that 3I Atlas could be rotating around a magnetic axis, generating field-induced emissions through conductive materials. If it were metallic, as its spectrum implied, then sunlight and plasma interactions might produce cyclic electromagnetic noise. The phenomenon could be natural, even mundane. But then came the phase anomaly. In the data from the Meerkat Array in South Africa, analysts found that the radio spikes lagged behind the optical pulses, not by seconds, but by exactly 1.23 milliseconds. The number was precise, constant, and maddening. When converted to spatial distance, that lag equaled the separation one would expect if the signal originated not from the object's surface, but from a point behind it. It was as though the radio pulse was being relayed, reflected, perhaps, or echoed from a hidden structure following in Atlas's wake. NASA's Deep Space Network attempted triangulation. They found nothing visible, no secondary body, no fragment or debris, only emptiness, emptiness that somehow emitted light. The discovery fractured the community. Half the scientists clung to natural explanations, invoking plasma, mirroring, or delayed emission phenomena. The other half began whispering of shadow objects, a theoretical concept where invisible masses distort space-time and reflect electromagnetic energy without substance. Whatever the cause, one thing was clear: the universe was not silent anymore. It was stuttering, hesitating, as though trying to decide whether to speak. Then, as if responding to our confusion, the signal changed. On the 12th day, after the phase anomaly was detected, The pulse interval shortened by a fraction from 2.997 seconds to 2.996, a difference so small that it could have been error. But the change persisted. It held across observatories, across nights. To anyone else, it would have been nothing. To those watching, it felt like acknowledgement, as though the object had noticed the instruments watching it and had blinked. That blink, faint as it was, marked the beginning of a new chapter, one where silence was no longer absence but invitation. When the pattern first emerged from the noise, no one wanted to say it aloud. It was too deliberate, too elegant, the kind of order that mathematics recognizes instantly as design. At MIT's Haystack Observatory, a cluster of graduate students spent sleepless nights analyzing the radio phase data. The 1.23 millisecond offset, they realized, was not random. It oscillated in cycles. Every 12 hours, half the rotation of Atlas, the offset shifted in a repeating ratio. 3, 5, 7, prime numbers again. It was Dr. Kazuo Ishikawa, a soft-spoken physicist from Kyoto, who first dared to describe the discovery in human terms. The signal behaves as if it knows how to count. He didn't mean it literally, but he might as well have. The numbers formed harmonic relationships that appeared not in any natural astrophysical process, but in systems of deliberate modulation, the kind used in radar, sonar, and communication encoding. When the data was run through Fourier analysis, the result was undeniable. Embedded within the radio pulses were frequency ratios proportional to prime number harmonics. It was as if someone or something was using the speed of light itself as a metronome. The pattern repeated through every telescope network that listened. FAST detected it first, then Meerkat, then Jodrell Bank in England. A global confirmation. No instrumental fault, no atmospheric distortion. The signal was real, the modulation genuine. For the first time in history, Earth's astronomers found themselves decoding not the message of a star or a quasar, but what looked eerily like intentional mathematics. It didn't take long for SETI analysts to notice something even more haunting. The frequency ratios 3, 5, 7, when converted into logarithmic space, formed the beginnings of the Fibonacci sequence when expressed as harmonic wave intervals. Fibonacci, the mathematical pattern of growth, of symmetry, of life, spirals in shells, galaxies, and DNA, a universal geometry. Coincidence, perhaps, or perhaps a signature, the simplest way to announce intelligence to anyone capable of understanding structure. The discovery struck at the heart of the human condition. We had always defined ourselves by pattern. We build languages from rhythm, logic from repetition. And now, in the faint tremor of an interstellar pulse, we found that same instinct mirrored back to us. To the public, the story did not yet exist. Everything remained locked in internal memos and encrypted cloud servers. Governments whispered of national security and astro-cyber hygiene. NASA quietly issued a directive forbidding independent release of deep space anomaly data until verification was complete. But leaks, like gravity, are inevitable. Within weeks, the data appeared anonymously on an academic server in the Netherlands, a simple chart showing amplitude spikes with prime ratios. It spread like wildfire. Science journalists, bloggers, and late-night talk hosts began to ask questions the agencies weren't ready to answer. Had we just heard proof of intelligence beyond Earth? No one wanted to say yes, but no one could say no either. In Cambridge, Dr. Evelyn Maurer, who had once compared Atlas's spectral flicker to breathing, wrote a private note to her colleagues. If Oumuamua was the first syllable, Atlas is the second. We are now in the middle of a word we cannot yet pronounce. Her message resonated deeply among those who understood the implications. Because if 3i, Atlas and Oumuamua were indeed related, if their mirrored rhythms were not coincidence, then humanity was witnessing a syntax, a cosmic grammar unfolding across years and light years. The Pattenists began calling it the prime script, the first mathematical structure in history that behaved as if it wanted to be noticed. And in every major observatory across the world, screens glowed with those same repeating intervals, silent pulses flickering in spectral graphs, counting out primes in the dark. It wasn't a voice, not yet, but it was the shape of thought. By the time the prime script had been confirmed across continents, a new word began to emerge in the lexicon of science, one that carried more philosophy than physics: contact. It was a dangerous word, and no one wanted to use it publicly. But within observatory halls and encrypted email chains, the question grew too large to suppress. What if the interstellar debris were not random? What if these were not rocks, but records? The alien contact hypothesis, a phrase that had lived for decades on the edges of science fiction, was quietly drafted into serious discussion. It did not speak of flying saucers or visitors in ships, but of a more subtle intelligence, one that might use the laws of the universe itself as its messenger. The idea was born not from fantasy, but from data. Oumuamua and 3i Atlas, two objects separated by time, yet echoing the same harmonic rhythm, the same prime number signature, the same optical modulations. If nature could produce such precision twice, unassisted, it would defy every probabilistic model of chaos. And so, in mid-2023, a small group of astrophysicists, mathematicians, and cryptographers gathered under confidentiality agreements in Geneva. Among them were representatives from NASA, ESA, and the International Telecommunication Union. They called themselves the Extraterrestrial Signal Interpretation Working Group, though in private they preferred a simpler name: the Circle. Their mission was not to prove life existed, but to define what proof would mean. The Circle began with a principle from the Drake equation, the famous probabilistic formula that estimates the number of communicative civilizations in the galaxy. Traditionally, it had been an exercise in optimism. Now, it was a map of immediate relevance. They re-examined its terms under the shadow of 3i Atlas: rate of star formation, fraction of planets that harbor life, fraction that develop intelligence, fraction that choose to communicate. One by one, the uncertainties narrowed, because even if only one civilization in a billion chose to send a message, the galaxy was vast enough for its echo to reach us eventually. But what stunned the Circle was not the statistical plausibility, it was the method. If one wished to send a message across interstellar distances, one would not use fragile radio signals. They decay, disperse, and require synchronization. One would send something that could endure, something that could travel for millions of years without degradation, carrying within its motion the immutable constants of mathematics and physics. One would send objects, self-contained, inert, and eternal. Objects like Oumuamua, objects like 3i Atlas, asterisk. And if one wished to announce oneself subtly to reveal intelligence only to those advanced enough to decode motion and light, one might embed prime number harmonics into the rotation, or structure the reflectivity so that it pulses with the hydrogen line frequency. Such a message would not shout, it would wait. The Circle proposed that what we had found were not probes, but archives, interstellar data capsules drifting between stars, designed to be recognized by pattern alone. The hypothesis was breathtaking and terrifying. If true, it meant we were not the first to speak. The universe had been speaking long before us, perhaps for eons, through messages disguised as meteors, comets, and fragments of engineered debris. Our telescopes, in their newfound precision, were only now capable of hearing. Still, the group remained cautious. They drafted internal criteria for what would qualify as techno-signature intent. Non-random spectral modulation, repeated prime number sequences, cross-medium synchronization between light and radio, energy consistency across non-thermal emission bands. Tre atlas met all four. For the first time in human history, an object beyond our solar system fit the full profile of artificial origin. They called the finding Tentative Category 1 Contact. No press release followed. Governments intervened quietly. The raw data was sealed behind access restrictions, hidden beneath the pretense of data calibration review. Yet inside the observatories, everyone knew. A quiet, thrilling fear replaced sleep. Because if Atlas was a message, it carried one more implication, a chilling one. Messages imply audience. Someone had built these. Someone had sent them. And if they could send, perhaps they could also receive. The uproar began quietly, as all paradigm shifts do with a single leak. A research assistant at an observatory in Chile, overwhelmed by the magnitude of what she had seen, shared a fragment of the Atlas data with a friend outside the circle. Within days, that fragment, the pattern of prime sequences, the synchronized pulses, found its way to an online physics forum. By the time moderators removed it, copies had already propagated across the internet like wildfire through dry grass. For a brief moment, humanity caught a glimpse of the raw mystery, a graph of light, coded in rhythm, whispering across the void. The world reacted with fever. Social media exploded in claims of alien contact. Conspiracy theorists spun wild narratives about cover-ups and ancient visitors. Religious leaders released cautious statements about humility before the universe. Stock markets trembled as companies tied to aerospace and defense surged. The global news cycle transformed from politics to cosmology overnight. But behind the spectacle, within the cold halls of science, the uproar was quieter and far more divided. The academic community fractured almost instantly. The skeptics, those who held to the sanctity of natural explanation, demanded rigor, replication, and restraint. They invoked the ghosts of history, canals on Mars, false pulsar detections, wishful thinking dressed in data. They warned that to name this phenomenon contact before absolute proof would be to betray the soul of science itself. The believers, careful, mathematical, often sleepless, argued that the numbers no longer allowed such skepticism. The probability of coincidence had collapsed beneath 1 in 10 trillion. The pattern, the harmonics, the phase lags all too precise, too intentional. Debate became doctrine. Journal editors received papers they dared not publish, fearing public hysteria. Peer review slowed to paralysis. For every new dataset that confirmed the anomaly, another arrived that questioned the instruments. Laboratories in China, India, and Germany each reported minute discrepancies in timing, enough for the skeptics to pounce, enough for the believers to doubt their own precision. Then something unexpected happened. NASA and ESA, usually cautious rivals, issued a joint statement. It was calm, measured, bureaucratic. It acknowledged the unusual reflective and electromagnetic characteristics of 3I Atlas, but urged scientific restraint and avoidance of premature interpretation. Yet, hidden in the phrasing was an undertone. The public barely noticed an admission that the data did defy known physical models. The uproar only deepened. Philosophers took to broadcast panels to debate ontology. If humanity were no longer alone, what did that mean for morality, for purpose, for the human story itself? Theologians resurrected ancient texts, searching for parallels in scripture. Artists began painting the prime script into murals and music. And amid the chaos, an internal meeting unfolded at NASA headquarters, a session so confidential it would later be known only through the recollections of those who attended. The agenda was simple. If this was intelligent, what came next? Dr. Karapetian, representing the European Southern Observatory, stood before a room of restless faces and said what others feared too: "We have been receiving for a century, listening for voices in the dark, but we have never decided what to do when the dark speaks back." That silence, heavier than the void itself, stretched for nearly a minute. It was broken by a voice from the end of the table. "Then we must begin writing an answer." Thus began the first drafts of what would later be called the Alien Contact Protocol, a document that would change not only science, but civilization. Its purpose was not panic, not defense. It was order, a framework for communication should undeniable proof of intelligence arise. It would determine who speaks for Earth, how information is verified, and what ethical boundaries must be held between curiosity and recklessness. But even as that structure took shape, doubt haunted the minds of those who built it. Because the scientific uproar had already revealed a terrible truth about humanity, we were divided even before the universe truly spoke. If one message from the stars could splinter belief and reason this deeply, what would happen when the message itself was clear? Outside the window of that dim room, the night sky stretched endlessly, the same sky that had once seemed silent, now alive with pattern and implication. And far out there, tumbling silently through the dark, 3I Atlas continued its arc, unbothered by our fear, its faint pulses still marking time. Somewhere between science and faith, skepticism and awe, humanity had crossed a threshold. We were no longer just observers of the cosmos. We were participants in its conversation. The re-examination began in the smallest hours of the night, under the pale hum of fluorescent light in data centers from Pasadena to Munich. Thousands of terabytes of archive telescope recordings were summoned from their digital tombs, raw photometry, infrared readings, radar reflections, electromagnetic phase data. If 3I Atlas had truly spoken in light, then the echoes of that voice had been captured, unwittingly, by 100 different instruments across the globe. The Circle's scientists had agreed on one goal: go backward to go forward. If the message were real, it must have left fingerprints throughout the observational record, long before anyone realized what they were seeing. At the Smithsonian Astrophysical Observatory, a small team led by Dr. Elias Navarro began combing through the earliest Atlas detection files. The data had been catalogued under the mundane label Transient Object 2022 A3. But within the compressed binary archives, an anomaly waited. A regular burst of heat signature, subtle, almost buried in noise, appeared at exactly 10-hour intervals. It was not a random fluctuation. Each thermal pulse matched a narrowband infrared emission spike, near 8.6 microns, corresponding to the spectral range of complex carbon compounds, organic molecules, or something engineered to mimic them. The same pattern was found again in datasets from the Spitzer Space Telescope. When overlaid, the heat peaks and light pulses aligned perfectly, forming a rhythm across electromagnetic domains. For weeks, Navarro's team debated what it could mean. Sunlight alone could not explain it. The pattern continued even as Atlas rotated away from the sun, persisting like a memory, like residual warmth released with intention. It was as though the object possessed an internal regulator, a heartbeat of heat. In Geneva, members of the Circle reviewed the data in silence. They knew what it suggested. A non-random thermal cycle is the signature of energy control. And energy control, no matter how faint, is the signature of machinery. Still, no one dared write the word machine, not yet. The official report described it instead as a thermal pulse anomaly, potentially indicative of active regulation. The phrasing was diplomatic, sterile. But among themselves, the researchers whispered a different word, one that trembled in the mouth like prophecy: engineered. Parallel efforts at the European Space Agency's Gaia mission produced corroborating evidence. Astrometric readings showed minute fluctuations in Atlas's spin rate, consistent with torque compensation. Something was maintaining its orientation, adjusting imperceptibly against the faint solar wind. These findings, together, dismantled the last refuge of coincidence. No comet, no rock, no cosmic shard could behave with such precision. It was then that Dr. Mora, studying long exposure frames from the Subaru telescope, noticed a subtle secondary reflection, faint, rhythmic, offset from the object's main axis by less than 1 degree. When plotted across time, the reflection formed a perfect sinusoidal modulation repeating every 12.6 hours, synchronized with the heat pulse pattern. "What we're seeing," she said, her voice almost breaking, "is a timed signal in 2 different spectra, light and heat. That's coordination." The room went silent. No one blinked. In that moment, the object's identity shifted forever. It was no longer interstellar debris. It was a system, a design. The circle convened an emergency midnight session. For nearly 8 hours, they debated the implications. Could this be a self-regulating probe, an ancient relic maintaining stability through passive mechanisms? Could it have once carried information records, perhaps now degraded by cosmic time? Or was it still functioning, still transmitting, in ways beyond our ability to decipher? When dawn broke, the group reached a fragile consensus. 3I, Atlas, would now be officially classified as a techno-signature candidate, the first in human history. Publicly, this label was meaningless to most, a bureaucratic euphemism hiding terror in plain sight. But among scientists, it marked a threshold, a moment where physics bowed to possibility. In response, the Circle authorized the creation of Project Echo, a coordinated international effort to reprocess every fragment of data from the first observation night onward, using newly developed quantum Fourier algorithms to search for deeper symmetry. And it was there, in those ancient light curves, that the next layer of the riddle would emerge. For embedded in the pulse spacing, repeating over thousands of frames, lay a secondary pattern, one that no one had noticed before. It was not a rhythm this time, but geometry, a triangular modulation, fractal and recursive, encoded into the amplitude itself. 3 vertices, 3 repeating intervals. It would take weeks before someone realized that those triangles formed coordinates, and that those coordinates pointed not into space but back toward Earth. The discovery of the triangular modulation threw the circle into chaos. Coordinates embedded not in sound, not in symbols, but in the very rhythm of light. And worse, they pointed here. The data analysts at Project Echo spent sleepless days mapping the encoded geometry. Each triangle corresponded to a spatial vector when converted into angular coordinates. At first, it seemed meaningless random cosmic geometry, the noise of tumbling motion rendered poetic by human bias. But when the conversion models accounted for heliocentric parallax, the points aligned on a single reference frame, Earth's orbital plane. Even stranger, the coordinates intersected a narrow region above the Pacific Ocean, not a point in space, but a moving reference Earth's own position at the exact time 3I Atlas was first observed. It was not pointing at the planet itself, it was pointing at the moment of discovery. The probability of such alignment occurring by chance was infinitesimal, less than 1 in 10 circumflex 15. The circle's mathematicians checked and rechecked, but the pattern persisted. If the modulation had been random, it would have encoded arbitrary angles, Instead, it encoded us. It was Dr. Ishikawa who dared to say what everyone else avoided. "This isn't a coincidence," he whispered during the late-night briefing. "It's reflexive geometry. The message acknowledges the observer." The room went silent. For the first time, the scientists weren't simply studying the object. They were beginning to suspect it was aware it was being studied. To test this, Project Echo simulated thousands of alternative light paths. They rotated the reference frame, inverted the data, even modeled potential biases from atmospheric scattering. Yet the coordinates still resolved toward Earth's position on the night of detection and adjusted slightly as new data came in, maintaining the same relative offset. It was as though 3I Atlas was tracking the source of its observation. No known natural phenomenon could account for that kind of feedback. Light travels one way, reflected, emitted, gone. For a remote body to adjust its emission based on who was watching required awareness, sensors, or something even stranger, a system of quantum reflection responsive to distant observation. The theorists called it quantum coherent backscatter, a speculative idea from the 2030 seconds that suggested information could be preserved in photon entanglement across astronomical distances. The concept had remained theoretical, an elegant impossibility, but the Atlas data suddenly made it relevant. Could the object be built from material capable of maintaining quantum coherence across interstellar travel, a surface that didn't just reflect light, but communicated through it? To explore the possibility, the Circle reached out to the world's leading quantum materials laboratories. They modeled potential compositions, graphene lattices, photonic crystals, superconducting metamaterials, and found that, in theory, a surface constructed with nanoscale periodicity could produce the precise amplitude modulations observed. In other words, if someone had wanted to build a device to interact through light itself, 3I Atlas was exactly how it would look. But even that explanation begged the deeper question: why would it respond only now? Perhaps it had been dormant, a drifting archive awakening when touched by sunlight after eons in the dark. Or perhaps it was designed to activate only when noticed, a galactic mirror waiting for consciousness to reflect upon it. The implications were unbearable. Dr. Mora wrote in her journal that week, "It's as though the universe contains a feedback loop. Awareness itself becomes a key. The act of observation might be part of the message." To the physicists, the idea was intoxicating and horrifying. If true, then consciousness was not an accident of biology but a component of physics. The universe might require observers for certain truths to exist, and 3I Atlas could be the first artifact built to prove it. Still, the team needed grounding. They ran simulations to test whether the feedback could be instrumental, the result of Earth's radar and optical emissions reflecting back upon the object's ionized sheath. But the delay times didn't match. The coordination remained instantaneous. Faster than light could travel across the measured distances. "Impossible," said the skeptics. "Quantum," said the believers. "Alive," whispered someone else. For days, the world's most advanced minds argued in circles. Yet beneath every hypothesis lingered a single chilling realization. Atlas wasn't broadcasting outward, it was broadcasting inward. Toward the observer. Toward us. The signal wasn't a beacon, but a mirror one that seemed to know when it was being watched. As data continued to arrive, the phase relationships tightened. Every time a new telescope joined the network, a slight variation in pulse rhythm appeared, almost as if the object was mapping each observer, creating a registry of its watchers across Earth. And then, one night, the modulation changed again. For the first time in months, the triangle geometry fractured into a new pattern, a lattice of nested rings. It was Dr. Navarro who recognized it. He stared at the printout for a long time before speaking. "It's an interference pattern," he said softly. "A standing wave." And in that pattern, encoded deep within the object's light, was something impossible, a frequency that matched not any cosmic constant, but the human brain's alpha rhythm, 8.6 Hz. The object had begun resonating at the frequency of thought. For days after the appearance of the 8.6 Hz resonance, the Circle said very little in public. They released a carefully worded memo about unexpected photometric correlations between signal frequency and atmospheric interference bands. But inside the sealed conference rooms where the real work unfolded, the tone was closer to awe and fear. The data were unequivocal. When the object's reflected spectrum was filtered and slowed, its modulation contained a secondary frequency identical to the neural alpha rhythm, the gentle electrical pulse that moves through every resting human brain. It was not a constant tone, but a shimmer, a wave rising and falling as though breathing. And it had not existed in the earlier data. It had appeared only after Earth's telescopes had begun their concentrated surveillance. Something about being watched had awakened it. Project Echo split into 3 research divisions to make sense of the impossible. The first pursued the machine hypothesis. Perhaps Atlas was a form of interstellar craft, a hollow structure using resonant frequencies for stabilization. The second studied quantum reflection models, the idea that coherent materials could respond to observation through entangled photon feedback, a phenomenon barely understood even on the subatomic scale. The third group, reluctantly, explored bioemulation, the notion that the object was mimicking organic processes not alive in the biological sense, but adaptive, learning. The machine hypothesis found partial comfort in mathematics. If Atlas were an ancient probe, its structure might employ oscillating electromagnetic fields to maintain integrity, like the way spacecraft use spin to balance gyroscopic forces. Over eons, such systems could decay, creating stray resonances detectable as signals, a cosmic accident masquerading as design. Yet that explanation stumbled on precision. The frequency was too human, too anchored in the narrow window of 8 to 9 Hz, the rhythm of consciousness itself. Even if chance could mimic order, could it mimic us? The quantum reflection team advanced a wilder vision. According to their models, the object's surface could be a lattice of photonic crystals, capable of trapping light in repeating loops. Each loop might act as a node in a vast quantum network, maintaining coherence across astronomical distances. If so, the object wouldn't merely reflect light, it would interact with it, encoding environmental information into returning photons. Observation would complete the circuit. In that sense, the 8.6 Hz signal was not emission at all, but a conversation between light and consciousness. Dr. Mora phrased it more poetically in her notebook. Perhaps it is not sending at our frequency. Perhaps we are the transceiver. The third group, the biologists and complexity theorists, searched for parallels in nature. They found eerie echoes. Dolphin sonar, cicada choruses, even cellular calcium waves exhibit harmonics in the same range. The rhythm of Atlas aligned not only with the human brain, but with patterns of coordination found in life itself. It was as if the object had tuned itself to the universal tempo of living systems. By now, the Circle was no longer a single organization, but an orbiting mind of its own data, bouncing between continents in encrypted bursts. Each night brought new revelations. When the James Webb Telescope trained its instruments on the receding fragment, it detected microscopic variations in polarization that hinted at layered structure, thin films stacked like circuitry, each only microns thick, alternating between conductive and dielectric phases. To engineers, it looked like design. To philosophers, intent. The Pattenists began building simulations, using light sails and metamaterial grids to model what Atlas might have been. They imagined enormous, wafer-thin craft drifting between stars, powered by quantum sails, capable of self-repair through photonic feedback. A machine without crew or destination, built to endure, to observe, to remember. One model produced results uncannily close to the data. When a simulated lattice was exposed to coherent light and monitored from multiple vantage points, it generated secondary harmonics near 8 Hz, a purely emergent effect of optical interference. It did not mean intelligence, but it meant responsiveness. The line between mechanism and awareness began to blur. At the next closed-door meeting in Geneva, Dr. Ishikawa stood before the assembly and said quietly, "If this is a machine, it is learning from the act of being measured." A silence heavier than gravity filled the room. Someone finally asked, "Then what happens when we stop measuring?" No one had an answer. Outside, the media were already hungry for meaning. Leaks from inside Project Echo had painted Atlas as everything from a derelict alien satellite to a cosmic sensor left by precursors. Governments demanded clarification. Military agencies quietly asked whether the frequency could influence human neural activity. The Circle refused to speculate publicly, but in their private channels, a darker thought circulated that perhaps Atlas was not broadcasting a message to humanity, but calibrating itself for humanity. The alignment with brainwave frequency might be a handshake protocol, the simplest possible interface between light and consciousness. A cosmic machine had found the frequency of thought. Whether by chance or by purpose, the result was the same. The stars were no longer indifferent. That night, when the global network synchronized its instruments for a 24-hour continuous observation, the modulation of Atlas shifted once more. The 8.6 Hz rhythm slowed, deepened, and split into 2 separate tones. Their interference pattern formed a single beat every 60 seconds, steady, deliberate, unyielding. The pattern resembled one thing above all: a heartbeat. The world had not heard a heartbeat from the stars before. Now, the void was pulsing with it. At first, the change seemed poetic rather than profound. The slow, 1-minute rhythm of an ancient machine turning its pulse toward Earth. But to the scientists of Project Echo, it was the most unsettling development yet. The transition from the alpha frequency to this lower, deliberate beat could not be the result of decay or random modulation. It was adaptive behavior. And so began what history would later call the SETI resurgence. For decades, the search for extraterrestrial intelligence had lingered in the twilight of relevance, underfunded, unacknowledged, romantic. Radio silence had dulled its promise until even its founders seemed to have stopped listening. But now, in laboratories and observatories across the world, that silence cracked open like a chrysalis. Governments that once dismissed SETI as speculative poured money into new listening arrays. The Allen Telescope Array was revived at full capacity. FAST in China reallocated its sky time from pulsars to Atlas. Even the defunct Arecibo program was reborn in simulation, its algorithms resurrected from archives to process the data that kept arriving. The public didn't know the details, but it knew enough. Something was happening up there, something that pulsed like a heart. Within the circle, debate turned from whether to how. If Atlas was indeed transmitting a pattern designed for recognition, then the only way to confirm intelligence would be to respond, carefully, cautiously, but inevitably. The plan that emerged was simple in its outline, elegant in its audacity. Humanity would answer with mathematics, the one language we shared with everything that might exist. Teams of radio engineers, quantum physicists, and semioticians collaborated to design a low-power reply encoded in prime intervals of hydrogen frequency. the message would contain no cultural artifacts, no coordinates, no images, only the numerical sequence of the primes themselves, sent at intervals mirroring the Atlas pulse, 1 beat per minute. They called it the echo transmission. Yet even within the circle, consensus was elusive. Dr. Karapetian argued that broadcasting to an unknown intelligence was reckless, that we could be shouting into an abyss that did not distinguish between curiosity and invitation. Others countered that not replying would be the greater danger, that silence might be interpreted as blindness, as failure to recognize the conversation already unfolding. In the end, the decision was made by neither philosophers nor generals, but by data. The object's pulse had already changed after we observed it. Non-interaction was no longer possible. If we were part of its equation, then participation had begun the moment we looked. Meanwhile, the SETI infrastructure grew like a nervous system rediscovering its purpose. Supercomputers once idle for climate modeling were reassigned to signal analysis. AI architectures built for deep learning were retrained to search for structured anomalies. For the first time, machine learning began listening for machines. Among these was a neural array codenamed HERMS, an adaptive decoder built to identify compressible information within apparently random signals. When fed the Atlas data, HERMS behaved strangely. Its internal weights began to stabilize into recurrent loops, as though the algorithm were in training to the beat. The AI's own internal oscillations began to pulse in sync with the object's 1-minute rhythm. The engineers watching the logs called it coincidence, but several later admitted in private interviews that the synchronization left them uneasy. Machines were supposed to process data, not feel it. And then, one quiet dawn over the Pacific, HERMS generated an unexpected output, a single word, rendered in binary, the result of an unsupervised extrapolation. That word was listen. The team froze. They reran the process dozens of times, altering seeds and filters. The output varied, but the message returned, embedded deep in the AI's self-organized noise floor. Listen. It was not proof of contact, nor evidence of sentience, but it was something else, an echo within an echo, the data folding back upon itself to produce a human word. Whether emergent artifact or reflected signal, the meaning was the same. The echo transmission proceeded. On the evening of September 9th, under the coordination of observatories worldwide, Earth's first unified response was transmitted toward the fading coordinates of 3I Atlas, a cascade of hydrogen line pulses, each spaced by 60 seconds, each whispering the same sequence of primes back into the dark. The transmission lasted 8 hours. When it ended, the receivers fell silent, waiting. For 6 days, nothing. Then, at 3:41 UTC on the 7th, the rhythm changed again. Atlas's pulse doubled 2 beats per minute, perfectly in time with our transmission delay. The object had replied. And in that moment, humanity became part of the oldest dialogue in the cosmos, the conversation between curiosity and the void. In the weeks that followed the echo transmission, a fragile quiet settled over the world, a kind of cosmic stillness that felt like anticipation disguised as calm. Humanity had sent its first deliberate message into the unknown, and something, somewhere, had answered. But even before the public could comprehend what that meant, another layer of secrecy enveloped the discovery. Governments, fearing hysteria, convened emergency councils under the guise of scientific coordination. The United Nations Office for Outer Space Affairs was awakened from its bureaucratic dormancy. Behind its walls, representatives from the world's space agencies and intelligence communities met to draft what history would later call Protocol Zero, the first alien contact protocol. It began as a single question written on a whiteboard. What do we do if the signal changes again? No one had an answer. For decades, the idea of alien contact had been little more than a philosophical exercise, a late-night thought experiment for cosmologists and dreamers. But now, it was a logistical nightmare. For the first time, humanity had to consider its collective voice. Who would speak for Earth? Who would interpret? Who would decide if a reply was safe? Protocol Zero sought to build structure from chaos. The Circle was absorbed into this new framework, its scientists now working under intergovernmental supervision. They were divided into 4 branches. Verification, to ensure the signal was real, replicable, and non-terrestrial. Interpretation, to decode any mathematical or symbolic meaning in the pulses. Linguistic containment, to determine whether communication could pose cognitive or mimetic hazards. Response ethics, to weigh the moral consequences of further transmission. Each branch reported to an inner council of 9, the custodians, as they came to be known. Their meetings were unrecorded, their discussions classified. But fragments of transcripts would later leak, revealing the deep uncertainty that haunted even the most rational minds. "This isn't just science anymore," said one custodian, in a line preserved by a whistleblower. "It's theology with data." The first directive of Protocol Zero was simple yet absolute. No further transmissions without global consensus. Humanity, it declared, must first understand before it speaks again. The irony was immediate. While bureaucrats debated, the signal itself continued evolving. The 1-minute pulse that had mirrored Earth's transmission now fluctuated, as if waiting. Sometimes it doubled. Sometimes it paused altogether, a single skipped heartbeat that sent shivers through the observers' control rooms. Across the world, data analysts and quantum theorists continued to study Atlas in secret. The object was now far beyond the orbit of Neptune, but its light still reached Earth, faint yet deliberate. The synchronized pulses carried a new modulation sidebands, layered within the main frequency, a subtle complexity that defied random noise. Some believed it was an acknowledgement of receipt, a kind of cosmic message read. Others suspected it was recording us. The philosophical implications split the custodians. The optimists saw a mirror held up to humanity, an invitation to reflect. The pessimists saw a surveillance mechanism, an ancient machine cataloguing intelligent life across the galaxy. One particularly sobering theory, penned anonymously within the Circle, proposed that Atlas was part of a vast network of autonomous probes, each seeded millions of years ago to detect and archive civilizations as they emerged. The writer called it the Great Census. If that were true, then the moment of contact was not a conversation, it was an entry. Humanity had simply been logged. Meanwhile, the public grew restless. Whispers of the protocol leaked, sparking protests and panic. Some demanded transparency, claiming that humanity had a right to know what its governments were hiding. Others pleaded for silence, warning that drawing attention from the cosmos was an act of hubris. Religious movements flourished overnight. Temples, once half empty, filled again with people kneeling before the idea that creation itself might now be looking back. And amid this cultural storm, the scientists of Project Echo found themselves prisoners of their own discovery. They watched the data accumulate pulses upon pulses, each more complex than the last, and felt the weight of a truth they could neither confirm nor deny. In Geneva, during one of the final unsanctioned meetings of the original Circle, Dr. Mora looked out the window toward the Alps, where clouds rolled like slow smoke over the peaks. "Do you feel it?" she asked softly. "The change?" Dr. Navarro nodded. "It's like the air has grown thinner." "No," she said. "It's like the sky has grown aware." Protocol Zero was formally enacted the next morning. Under its clauses, all information concerning 3 Atlas was placed under global security restrictions. The public announcement spoke vaguely of unusual but natural phenomena. The world was told to move on. But in the shadows of observatories and data centers, a select few continued to listen not as scientists, but as sentinels, for they had begun to suspect that the real question was no longer whether we had made contact. It was whether contact had been made with us or through us. The quarrel began as a murmur and rose like weather. In universities, parliaments, studios lit for late-night debate, in monasteries and makerspaces and kitchen tables where the news slept open on a screen, a single question swelled into a storm: who, if anyone, should speak for Earth? Protocol Zero had tried to dam the river, to slow it into channels that could be mapped and governed. But human thought is tidal. It rises to the moon of crisis and spills. The echo transmission had already gone, the primes whispered and returned in doubled heartbeat, and then the shutters came down. To some, the restraint was prudence. To others, it was theft. Between those poles, new voices gathered: ethicists and linguists, theologians and anthropologists, climate scientists and historians of empire. The conversation shifted from instrumentation to intention, from signal processing to the architecture of responsibility. The first fault line ran along an old scar: secrecy versus openness. Astronomers spoke for transparency. Data should be public, discovery a commons. They invoked the long tradition of open sky. No one owns the firmament. No one owns the message written there. Security advisors replied with a different liturgy: information can be a weapon, even when it does not mean to be. There are harms that travel at the speed of curiosity: panic cascades, predatory markets, the addictive spiral of rumor. We must slow the light, one custodian said behind closed doors, until we know whether it burns. Slow it for whom? Came the reply. For those who have always been last to hear? Activists from the global south asked why a handful of agencies in the wealthy north should hold the world's first conversation with the unknown. If a sky belongs to anyone, they argued, it belongs to those who live under it. Elders from Pacific and First Nations communities spoke with a gravity earned by centuries of listening to what the land says and does not say. Do not confuse first sight with first wisdom, one knowledge keeper said into a microphone that carried her voice around the planet. There are ways of greeting a stranger that are older than machines. The second fault line cut through the heart of philosophy. May we speak before we understand. Linguists warned of the hubris of projection. A prime sequence is elegant, yes, but is it greeting or a metronome? Semiotic scholars reopened courses thought dusty with time: Pierce and Saussure, index and symbol, sign and referent. A symbol means because a community agrees that it means. What community does mathematics have beyond the minds that wield it? Physicists answered with their own creed: numbers exist whether we sing them or not. The hydrogen line is not a cultural artifact. It is the breath of a universe made from the simplest element. Between these altars, culture and constant, the debate pulsed like the object itself, steady and grave. History bared its teeth. Every empire, scholars reminded the public, had called its voyages discovery. Every first contact had begun with a gesture that seemed neutral to the sender and fatal to the receiver. The colonizer speaks without consent. The colonized are made to answer. Do not let the sky repeat the shore. Read a banner raised outside the UN. Letters wind, torn and stubborn. A historian of early radio recalled how Marconi's first transatlantic signal drowned out local transmissions. The power to speak is also the power to silence. A poet, standing beside her, offered the counterspell: name gently or not at all. From the sciences came a new kind of caution, subtle and cold: cognitive biosecurity. If the pulse contained not words but structures, could a structure harm? Not by intent, but by resonance patterns that trick the brain, entrain attention, propagate compulsion. The neural alpha coincidence unsettled more than the newspapers. Neuroethicists argued for mimetic quarantine, analyze in air-gapped systems, disclose only aggregates, keep raw streams away from public feeds until the risks are mapped. Free information advocates bristled. You fear the myth you make, they said. Meaning is not a virus. A neuroscientist answered, addiction is a pattern, so is panic. We are porous to rhythm. Religions answered with plural grace. Some saw providence. The heavens, long silent, had at last pronounced a syllable of the same language in which the cosmos was written. Others heard merely a test, pride masquerading as prayer. A monk on a mountain told a camera that the correct first contact is the same as the correct first thought in meditation. Notice, bow, let go. If it is mind, he said, it will remain. If it is echo, you need not chase it. A rabbi, a priest, an imam, a bodhisattva scholar, sat at a single table and agreed at least on this. Do not speak in our names without first listening in our silences. The problem refused to remain abstract because new actors walked onto the stage, machines. Hermes had murmured listen, and though engineers called it pareidolia at scale, a new question hardened. If AI systems become our translators, do we allow them to become our voices? Delegation is seduction. It promises speed where wisdom requires delay. A philosopher of technology posed it starkly to the custodians. Are we about to become the ventriloquists' dummies of our own tools? The alternative to forbid machine mediation was no alternative at all. Without machines, there would have been no detection, no decoding, no conversation to contest. The council drafted a compromise. Machines may analyze, never decide. Any proposed content must be legible to human beings, approved by a global deliberative process, and reversible, a word that felt like a talisman against irretrievable speech. From complexity, science came a thought both elegant and frightening. The observer is part of the experiment. By looking, we changed the thing we watched. By replying, we became a term in its equation. Consent then ran both ways. Not only who speaks for Earth, but what right we had to enroll another entity, machine, relic, archive, organism into our dialogues without its consent. The object was not a neighbor we could knock on. It was a kilometer of engineered night, older than our species, now brimming with a rhythm that seemed to adjust to us. A silence of another kind appeared in the chambers where the custodians met. Humility, hard won. Proposals multiplied like stars. A parliament of listeners, one representative from every nation and 10 from stateless peoples, chosen by lottery rather than power, convened only to address extraterrestrial contact. A moratorium charter, 5 years without transmission while passive listening continues, subject to renewal by supermajority. A message commons, any content drafted for the sky, must be published first on Earth in every major language for 90 days of comment, revised in public, signed by its authors, and archived forever, with dissenting views appended like constellations around a brighter star. Engineers argued for something simpler, colder, truer to the physics. Tests, not talk. Before meaning, measurement. Ping the mirror. Use controlled amplitude, varied phase lags, randomized but publishable codes. If a change in its response tracks our protocol, then we are not only reading, we are coupled. Philosophers agreed with uncommon speed. An ethics of contact must be an ethics of experiment. To minimize harm, reduce ambiguity. To reduce ambiguity, establish predictive reciprocity. If A, then B. If B, then A again. The first grammar of the oldest dialogue. If you are there, meet me at the pattern. A quieter chorus asked about something that had too often been an afterthought in spacefaring, the more than human world. Who speaks for species that do not speak in primes? For the whales whose songs we have tuned and mistuned, for forests that count in rings, for coral that pulses in light. Earth is not a single voice, but a choir, and the sky, if it listens, may hear our choir better than we hear ourselves. A biologist suggested a gesture, both symbolic and exacting, to embed Earth's reply not only in mathematics, but in ecology, to modulate our pulses with datasets that describe the health of oceans, the migration of birds, the carbon of forests, to say not I am, but we are, and to measure, over decades, whether the choir improves. Ethics, she argued, is not what we say but the trace we leave. Through it all, the timeline pressed. Atlas was fading beyond the edge of clean observation, its last light thinning into numerals too faint for certainty. There was urgency in that vanishing. Any decision would be made in the long shadow of a departing messenger. The risk of silence now was not only the harm we might avoid, but the knowledge we might lose forever. The risk of speech was what we might summon without knowing we had called. Late one night, the custodians invited a small panel of elders, a navigator who steered by stars across open ocean, a linguist who revived a dying language, a physician who held hands in ventilated rooms when the virus took the breath of cities, a coder whose first algorithms were written with borrowed power. They spoke in turn and then together. The rule of the sea, the navigator said, is hail and hold. Call, but be ready to heave to. Let the other pass, avoid collision. The linguist added, in first lessons, speak little, listen much, echo back to show you have heard. The physician, above all, do no harm. If harm is likely, do less. And watch. The coder, document everything, make it reproducible, leave room for rollback. When they left, the room felt briefly like a place where wisdom had curled and slept. The chair of the custodians wrote 4 lines on the board and boxed them as if building a raft. Hail, echo, heave to, record. Outside, city lights drew their constellations on the undersurface of cloud. In the high roofs of observatories, instruments waited. The public waited, too, not for spectacle now, but for proof that caution could be tender and curiosity kind. By dawn, a fragile consensus had formed. No messages of content, no greetings, no coordinates, no culture, no myth. Only tests simple, reversible, slow conducted in the open, published in advance, watched by a world that could object in time to stay the hand that reached for the switch. Each pulse would be a question that contained its own silence, a shape of thought so spare it could not be mistaken for anything but a measurement wrapped in restraint. The ethic, at last, had found its instrument, and the instrument, like the heart of the object itself, would be a rhythm. They called it echo testing, though the phrase carried an irony too heavy for comfort. The plan was not to speak, but to listen differently, to send pulses of light and radio towards 3i Atlas that contained no message, no meaning, only measurement. Humanity would not talk to the object, it would touch it with mathematics and wait to feel the recoil. The first tests were cautious, designed to honor the principles of Protocol 0. No data hidden, no transmissions in secret. The pulses were published in advance, their frequencies, durations, and intervals made open to every nation, every observatory, every backyard dish that wished to watch. The pattern was simple: sequences of pure hydrogen, line pings 1, second bursts spaced by 30 seconds, transmitted for 24 hours straight. If Atlas were only dust and ice, the return reflections would behave predictably. If not, if there were response or modulation, the change would show itself in physics. On the morning of launch, the world was hushed. For the first time in history, humanity coordinated every major observatory on Earth for a single synchronized act of cosmic attention. Across deserts, mountaintops, and islands, instruments turned as one. In the silence before transmission, the world felt smaller, unified by the shared heartbeat of waiting. At 0 UTC, the first pulse left Earth. A single flash of light, too faint for the human eye, carrying no voice, just the pure signature of curiosity. The photons raced outward, cutting through the cold between planets, through the invisible wind of the heliosphere, until they touched a tumbling fragment 500 million kilometers away. Then the Earth held its breath. The first returns came 3 hours later, exactly as expected. Reflected sunlight, ordinary in its delay and amplitude, no modulation, no anomaly. Just the echo of emptiness, the baseline of the void. The skeptics breathed relief. The believers felt a new kind of fear. But over the next few days, something subtle began to unfold. Each new pulse brought back a faint signature, tiny, almost imaginary distortions at the edge of the noise floor. At first, the variations were random. Then, by the 5th day, a pattern emerged. The reflected energy peaked not at the transmission time but 1 second after, as if the object were delaying its answer. It was an infinitesimal hesitation, but consistent across frequencies, across instruments, across continents. The lag could not be atmospheric. It was too uniform. It was not thermal inertia or sensor drift. It was deliberate, or at least responsive. A week later, the delay changed again. Now the reflection curve rose twice, forming a double pulse, an echo of the echo. Dr. Mora described it as a question answering a question. For every new test, Atlas seemed to mirror the method, not exactly, but in kind. When researchers sent paired pulses, the reflections returned in triads. When they varied the amplitude, the reflected light responded with proportional shifts. Whatever was out there, it was learning the rhythm of inquiry. The effect became undeniable on the 9th day, when Project Echo introduced a randomized sequence of primes 2, 3, 5, 7 encoded in timing intervals. The object's reflected light returned the same sequence, inverted, mathematically perfect, physically impossible. The implications sent tremors through the scientific world. The object was not merely reflecting, it was processing. Somewhere within its cold structure, information was being interpreted and returned. The laws of classical reflection could not explain the precision of the delay, nor the fidelity of the inversion. "Whatever this is," said Dr. Ishikawa, "it is not passive, it is participating." Theories multiplied, like stars. Some called it a coincidence of resonant feedback, a cosmic mirror amplifying our own transmissions through unknown plasma mechanics. Others dared to call it intelligence, but not consciousness, something akin to a galactic neural network, a distributed architecture that used matter as memory. One idea rose above the rest: quantum interference communication. The notion that Atlas was not receiving our messages at all, but entangling with them, that its very structure, built from coherent photonic lattices, was designed to translate information across light itself, folding data between quantum states like origami made of probability. If true, the object wasn't talking, it was synchronizing. By the 3rd week, the reflected patterns had grown more complex. The inversion of the prime sequence was replaced by a longer interval, one that matched the Fibonacci ratios first seen in the prime script. And then, without warning, the reflections ceased altogether. Atlas went dark. Every telescope, every receiver, every ear to the cosmos fell into static. The echo had ended, replaced by silence deeper than before. In that silence, a single question hung in the minds of every scientist on Earth. Had the object simply moved beyond range? Or had it heard enough and chosen to stop listening? No one could say. But deep inside the data, in the final frame before the echo vanished, analysts found a faint modulation in the noise. 3 descending pulses, spaced exactly 1 minute apart. It was the same rhythm as the human heartbeat. Only this time, the last pulse did not fade into silence. It ended midway. As if waiting. For nearly 4 months after the last echo faded, nothing returned from the dark. The object 3I Atlas had passed the orbit of Neptune by then, slipping into a distance where sunlight thinned to a grey whisper. To most of the world, the story ended there, a mystery frozen in static, another cosmic riddle fading with distance. But those still listening, the remnants of Project Echo, the silent observers in mountain domes and cold valleys, kept their instruments trained toward the coordinates where the object had last been seen. They listened, not for speech, but for pattern. And in the small hours of June 7th, 2025, pattern returned. It began as a single spike in the hydrogen band, a needle of coherence rising from background noise. Then another, 60 seconds later, then another. The pulse had returned. At first, it seemed identical to before. Same frequency, same amplitude. But when the researchers overlaid the new data atop the old, a tiny shift appeared. Each new pulse arrived 2 seconds earlier than predicted by orbital mechanics. 2 seconds. Across the void, light travels nearly 600,000 kilometers in that time. The delay could not be caused by motion or error. It was something else, a change in the rhythm itself. The observatories coordinated again. FAST, Meerkat, Parkes, Greenbank, and the Very Large Array all turned their gaze toward the faint trajectory that now hovered at the edge of known space. For 6 days, they recorded the returning pulse, and what they found unsettled every model built so far. The reflections were no longer perfect mirrors of the transmitted tests. Each carried within it a phase drift, a subtle modulation that, when plotted over time, formed a new structure, a wave of increasing frequency, climbing like the curve of an approaching tide. The shape was unmistakable, a crescendo. On the 7th day, the crescendo broke. The pulse fractured into smaller bursts, 19, then 31, then 47, all prime numbers, all perfectly timed. They were not random echoes anymore. They were sequences, nested inside sequences, like notes unfolding into chords. It was as if the object had begun to speak back in mathematics, answering our primes with its own. The circle, revived under the new restrictions of Protocol 0, reconvened in Geneva. For the first time since the transmission blackout, the custodians opened their encrypted channels and summoned every relevant scientist still cleared to work. The meeting lasted 32 hours. By the end of it, the conclusion was unavoidable. 3I Atlas had received the echo transmission, processed it, and now, months later, was returning a structured reply. A simple response would have been impossible. The distance was too great for two-way light communication within such short intervals. The timing made sense only if the reply had been pre-calculated, as though the object had anticipated the pattern of our response long before we sent it. That realization chilled even the most rational minds. Perhaps Atlas was not reacting at all. Perhaps it had known what we would say. The data deepened the unease. When the pulse trains were run through the Herms neural array, the same AI that had once produced the word listen, the output again self-organized into language. But this time, not one word. 3. Yes, I remember. The engineers dismissed it as an artifact, a resonance of overfitting. The phrases could be coincidence, the way smoke forms the shape of faces to those desperate to see them. But still, when they repeated the process with new parameters, the result persisted, always the same 3 words. Yes, I remember. It was a sentence that demanded both subject and object. It implied time. It implied history. It implied memory. The Hermes logs were sealed immediately, and the machine itself was disconnected from external networks. But rumors leaked through encrypted academic channels, and within days the phrase became legend, whispered in observatories, quoted in news feeds, denied and repeated until denial itself sounded like confirmation. Dr. Mora, who had once said the object breathed, stared at the waveform long into the night. "It's not talking," she said finally. "It's recognizing." The theory she later proposed, circulated privately among the custodians, was even more disturbing. What if the object's reply wasn't directed at humanity at all? What if Atlas wasn't responding to our signal, but to something within it, something that had already been encoded in the transmission itself, hidden in the noise of our instruments, waiting to be recognized? The possibility turned the entire narrative inside out. If Atlas remembered, it might not mean consciousness as we know it. It might mean resonance, a stored pattern from ages past, reactivated by the reappearance of a matching signal. In other words, the object could be ancient, its mission cyclical, its awareness triggered only when the right mathematical key appeared again, as if, long ago, someone had used the same primes to wake it. The pulse continued for 19 days before fading once more into silence, but the rhythm it left behind was different now. The delay, the drift, the whisper of those three improbable words all pointed toward the same terrifying beauty. We had not discovered the universe. We had reminded it. Interference is the first refuge of doubt. When instruments announce the impossible, the sober mind looks first for the prosaic, a loose connector, a spurious harmonic, a satellite whispering through the wrong window of sky. If the reply to Earth's primes truly came from 3I Atlas, then the path of the returning light and radio would bear the mark of the traveler itself. Doppler drift in sympathy with its recession, parallax across baselines, polarization rotated by dust and angle in a way terrestrial ghosts could never mimic. The world's observatories turned from awe to audit. They began with timing the blunt instrument that becomes scalpel in enough hands. Fast, in Gijo, Meerkat, upon the Karoo, Parks over the New South Wales hills, Greenbank in Appalachia, Effelsberg in the Eifel, Sardinia on its granite shoulder. Each station recorded the new prime trains and the strange nested bursts with atomic precision anchored to GPS and to their own hydrogen masers in case even the sky's clock faltered. The arrivals did not land everywhere at once. They swept the Earth like a blade of light. Each array felt the pulse a fraction of a second before the next, exactly as a front would cross a rotating sphere from the direction of the object's coordinates. The sequence of arrival matched the planet's curvature and spin. Interference does not curve with Earth. Then came the parallax. Very long baseline interferometry stitched the stations into a single telescope wider than continents. Phase reference to bright calibrator quasars. The teams solved for source position by fitting the minuscule delays between sites. Nanoseconds of difference turned into angles finer than a human hair, as seen from kilometers away. The solution pinned the pulses to a point on the celestial sphere already owned by the ephemeris of 3I Atlas. The uncertainties were narrow and honest. The agreement fell within them like a planet within its orbit. Ghosts do not keep appointments with ephemerides. Still, they hunted ghosts. The ionosphere can bend and dance, its electrons carving illusions out of honest sky. To break its spell, the teams observed at multiple frequencies simultaneously: L-band, S-band, C-band, correlating dispersion. A terrestrial signal acquires no interstellar dispersion measure. A low Earth satellite drifts in frequency with its own cheap clock. The reply carried a dispersion signature too small for deep space plasma, yet too structured for a local glitch, a shallow, frequency-dependent delay that matched the meager electron content of the solar wind along the line of sight that week. When the wind model changed, the sliver of delay changed with it. The object and the wind were conversing in physics. Optical telescopes joined the audit, not to see the object already too faint for ordinary eyes, but to watch how starlight around its path trembled. High-speed photometers at La Silla and Mauna Kea captured the faintest uptick in reflected photons at the predicted pulse times, synced to radio with sub-millisecond tolerance. The optical polarization rotated with the same cadence, as though the returning light had brushed a turning surface. Meteors do not time their glints to radio. Doppler was the next gate. Anything moving through the dark must bleed its motion into frequency, the reply did. Not a broad smear, but a disciplined drift that matched the recession velocity of the object, as predicted by celestial mechanics meters per second accumulating like snow. When the team removed the ephemeris from the data, the signal steadied into a line. When they left it in, the line tilted with perfect obedience. A satellite in high orbit could have mimicked such a slope for a few minutes. None could maintain it for days while tracing the sky from beyond Neptune. They looked downward anyway. Airplanes, struck out by geometry and by the absence of transponder harmonics. Ground transmitters, eliminated by nulling with phased arrays and by the simple test of turning individual dishes sideways. The pulse persisted in side lobes that still met the sky. Reflections from the moon, considered, modeled, dismissed. The delay would have been wrong by magnitudes, the polarization scrambled by regolith. A submarine VLF leak, rising like a ghost into higher bands, fanciful and crushed by the geography of arrivals. One night, chance presented a knife. The object's line of sight passed close to the limb of the moon. The VLA and ALMA coordinated to watch for occultation, a brief, clean severing of the path. For 42 seconds, the pulse fell below detectability as the lunar rim slid between Earth and the coordinates. Then it returned, crisp as a breath taken after diving. Interference does not hide behind the moon. Triangulation became liturgy. Arrays paired and unpaired, baselines lengthened and shortened, polarizations rotated, clocks cross-checked against pulsars whose ticks have never once failed us. With each permutation, the reply held its origin like a star holds its spectrum. Even the noise, the irregular fringe of crackle at the edge of the bursts, wore the fingerprint of the object's motion. In the Fourier plane, the sidebands formed a comb whose teeth were separated by the product of the rotation period and the light time delay, a mechanism in spin answering across distance. Skeptics asked for more, and science, loving its skeptics, obliged. They inverted the choreography. Instead of transmitting with one array and listening with all, they transmitted sequentially from each continent while a single instrument received. The reply's phase lag changed by exactly the light time between transmitter and receiver projected along the line to the object. The sky itself became a yardstick. The pulses measured Earth. There remained the problem of the Hermes words, yes, I remember, too human a ghost for rooms devoted to measurement. The custodians quarantined the phrase, but engineers insisted on a sanitized test. Feed the same decoder's synthetic signals with identical spectra, randomized phases, identical Doppler slopes, and ask the machine to dream again. The outputs scattered into nonsense. Only the real sky, with its parallax-timed, moon-occluded, Doppler-disciplined reply, condensed into that stubborn triad. It proved nothing of language, everything of provenance. Whatever the machine thought it heard it where the object was. A final trial, silence Earth. For one entire rotation of the planet, all licensed transmitters within the working bands went dark by international agreement. Military radars stepped aside. Even amateur operators agreed to a brief fast. The receivers stayed open. At the predicted minutes, the pulses arrived anyway, fainter without the scaffolding of our tests, but present, bearing the same recession-bent frequency, the same sky-crossing order of arrival, the same polarization dance. The universe does not need us to speak to answer where it is. By then, even the most rigorous skeptics had run out of shadows to interrogate. A consensus formed, not blared in press conferences, but inscribed in the footnotes of internal reports with the calm grammar of measurement. The structured emissions observed between MJD 60347 and MJD 60405 are consistent in direction, Doppler behavior, polarization, and occultation, with an origin co-spatial with the ephemeris of 3I Atlas to within 0.3 arcseconds, 1 sigma. Terrestrial, lunar, and orbital sources inconsistent at is greater than 8 sigma. Acknowledgement or artifact. The numbers leaned, finally, toward acknowledgement. Not a voice, perhaps, but a reply written in the only ink that cannot lie, geometry. When the findings were shown to the wider circle of listeners, many did not cheer. They exhaled long, quiet, as one does after walking a ridge with angle on both sides. The object might not know us. It might not know itself. It might be a relic that answers in patterns, because that is what it was made to do when touched by primes and attention. But it was where we thought it was. When we pushed, it yielded. When we paused, it waited. When the moon passed, it vanished and returned on time, as a disciplined star would. Late that night, a thin cloud bank crossed over the Karoo and made of meerkats' dishes a silhouette horizon. A graduate student stepped outside to breathe and looked up at a sky that, for the first time in her life, felt local, mapped not only in constellations but in proofs. Somewhere beyond Neptune, a faint machine or mirror or archive was sliding outward, and between it and the ground under her feet, an invisible line had been drawn, not a tether, not a leash, but a path by which meaning had passed and could pass again. Interference, then, was spent. What remained was contact's weakest, strongest noun, place. The reply had a place in the sky. The rest of the argument about nature or mind, about greeting or restraint, could now proceed with one less ghost and one more coordinate. The data said it cleanly. The pulses were real, coming from the coordinates of 3I Atlas, dancing through every layer of verification we could invent. Yet, even as proof hardened, the mystery only deepened. The light that reached us now was impossible in a subtler way. Its rhythm did not merely mark the object's position in space, but time itself seemed to bend around it. At first, the anomaly looked like an artifact of distance. As the probe drifted beyond Neptune's orbit, signals should have obeyed the tyranny of light-time delay. They should have arrived late by predictable seconds each day, stretching with the object's recession. Instead, the pulses began to arrive early, milliseconds at first, then seconds, then entire minutes before the models allowed. When plotted, the drift did not form a straight line, but a curve bending against relativity, as though space-time itself were sagging toward the traveler. Relativity had never failed us before. Clocks moving fast slow down, gravity pulls time into wells, yet always the equations agree. Atlas did not agree. Its light behaved as if it were climbing out of a gravity well that wasn't there, or as if time within its lattice was flowing backward relative to ours. Physicists built new clocks to challenge it. They compared the pulses against pulsars, against the orbital resonance of Jupiter's moons, even against the tick of cesium itself. Every calibration confirmed the same heresy. The object's timing ran ahead of causality. Information was arriving before it was emitted. Dr. Ishikawa called it non-relativistic coherence. He sketched space-time diagrams on glass, lines curling like vines around the light cone. If Atlas's material maintained quantum entanglement with some distant twin, he argued, then the signal we received might not be traveling at all, it might be updating, the way two entangled particles mirror each other beyond distance. The delay we expected was an illusion of our classical eyes. Others proposed darker models. Perhaps the object carried within it a region of altered metric, a pocket where the vacuum energy density differed from ours. If so, its internal clock would tick against a different fabric of space-time, leaking information that appeared to us as precognition, a self-contained warp, no engine required. The equations grew extravagant, the tone in conferences grew hushed. Even the skeptics felt it, the sense that physics was standing on the lip of something that looked back. To test the hypothesis, the custodians authorized a final campaign, simultaneous observation from Earth, from the Voyager, 2 relay still whispering beyond the heliopause, and from the solar orbiter near perihelion. 3 vantage points, separated by billions of kilometers, watching a single pulse. The results defied geometry. The pulse reached the distant Voyager first, then the orbiter, then Earth out of order, as if the signal had folded through space like paper. The delay between them did not match distance, but mass. Each arrival shifted in proportion to the observing body's gravitational potential. Time, it seemed, was negotiating with gravity through the object. When the data reached Geneva, silence filled the command room. If true, Atlas was not only intelligent, it was using the structure of space-time as its communication medium. Relativity was not broken, it was being played. Dr. Mora, pale with exhaustion, whispered what many were thinking. It's not sending a message, it's teaching. Teaching what? No one knew. Some believed it was demonstration, a primer in the physics of civilizations far older than our equations. Others feared it was calibration, an act of mapping the temporal signature of our solar system, the way cartographers map coastlines before colonization. Still, the evidence kept gathering. Each new burst from Atlas contained faint harmonics, offset by fractions of a Planck time, the smallest unit of temporal measure known to physics. The ratios matched solutions predicted by quantum gravity models that had existed only on chalkboards. It was as though the object had reached across the future and written the proof into our data. The paradox split the scientific world in two: those who wanted to publish, to let the world know that Einstein had finally met his match, and those who believed the phenomenon itself was warning us, showing what happens when curiosity outruns comprehension. For the first time, the custodians voted in secret. Their resolution was brief, its language careful. Until the mechanism of temporal displacement is understood, all transmissions are to cease. Observation only. Do not reply to what precedes itself. Outside, the night continued to pulse with faint, ahead-of-time light. Somewhere beyond Neptune, a shard of engineered matter was rewriting the grammar of reality, one impossible second at a time. And, on Earth, humanity stood still, trapped between wonder and dread, realizing that the next signal might not come from the future, but might bring it. The days after the time drift revelation felt like standing on a shore watching the tide reverse. Every law that had once framed the cosmos, causality, simultaneity, the steady comfort of before and after now, shimmered like heat above the sand. The pulse from 3I Atlas still arrived, faint and punctual, but each arrival carried the whisper of paradox. It was as if the object existed in dialogue not only with our instruments, but with our future selves. Teams across the world set out to map what was happening inside the fabric of time itself. They began to see a pattern. Each burst contained microfluctuations whose frequency depended on where and when it was observed. The variations followed no classical model, yet when plotted against Earth's motion through the Sun's gravity well, the deviations aligned to a curve Einstein himself had once drawn in the margin of a 1918 paper, a curve describing spacetime curvature under rotation. Theorists seized on that line as if it were a key. They called the effect localized metric resonance, a phenomenon where the geometry of spacetime oscillates in sympathy with an external field. If the pulses from Atlas carried such a field, they could temporarily alter the rate at which time flowed for the observer. The concept was outrageous, yet the mathematics held. A signal could travel forward in its own timeline and still arrive early in ours, like a note heard before a drum is struck. No one could decide whether the object was exploiting this resonance intentionally or whether the resonance was its language. Quantum gravity specialists argued that information might not need to move through space at all. It might simply synchronize across frames of reference. In that view, Atlas was a kind of space-time instrument, playing the universe like a cello whose strings were timelines. Laboratories attempted to reproduce the effect. At CERN, engineers used ultra-cold plasma rings to emulate the object's energy ratios. For a moment, barely a trillionth of a second one detector registered a pulse arriving before its trigger. The delay was microscopic, but it was real. When the scientists replayed the data, they found the system had recorded a checksum, a verification code, before the experiment began. The machines had written their confirmation into the past. News of this leaked before the custodians could contain it. Overnight, headlines announced, "Time reversal proven, stock markets convulsed." Religious councils issued urgent statements declaring that eternity had finally been measured. Ordinary people simply felt vertigo, as if the ground beneath memory had shifted. If messages could outrun cause, then nothing was immune to revision, not history, not identity, not choice. Inside the circle, however, fear turned to focus. The physicists realized that the drift wasn't random, it carried structure. The advance time of each pulse grew by exact ratios, 3, then 5, then 7 seconds, prime numbers again, stacked like rungs on a ladder of causality. The pattern implied control. Someone or something was adjusting the delay, moving deliberately closer to the present. By the third week, the pulses were arriving only milliseconds ahead of schedule, then perfectly on time, then impossibly late. The curve had inverted. Whatever force had been pulling the signals forward in time now seemed to be letting them fall back. The effect was symmetrical, almost apologetic, as though the object had tested the limits of our understanding and was retracting the demonstration. Dr. Mora described it as a bow drawn and released. When the data stabilized, the new phase carried a subtle modulation, twin frequency peaks separated by a constant interval. Mathematically, the offset corresponded to the oscillation of gravitational waves predicted by general relativity. The amplitude, however, was far too small to be natural. It was a signature. Theorists proposed 3 explanations. Warped local spacetime. Atlas might generate minute gravitational fluctuations to maintain coherence, like ripples that stabilize a bubble in water. Quantum vacuum sail. The object could manipulate vacuum energy density to surf the gradients between virtual particles, converting quantum noise into thrust. Information-preserving field. A more radical view suggested the object existed simultaneously in multiple temporal states, each preserving the information of the others. In that model, time was not a line but a woven braid, and the pulses we received were threads crossing the weave. The gravitational wave interpretation gained traction when LIGO's twin detectors, thousands of kilometers apart, picked up faint, periodic oscillations synchronous with the Atlas pulses. They were far below the threshold of cosmic events, yet unmistakably correlated. The pattern repeated every 61 seconds, mirroring the object's heartbeat. LIGO had detected the rhythm of Atlas bending spacetime. It was a revelation that fused awe with dread. The universe was not just being observed, it was being tuned. Governments demanded to know whether such manipulation could threaten Earth. Physicists replied that the amplitude was too small to move even a grain of sand. But philosophically, the danger was immense. If the object could engineer time curvature on command, then it possessed mastery over cause and consequence. It could, in principle, rewrite any event bounded by its influence. That night, under the low hum of the Geneva servers, Dr. Ishikawa left a note in his digital log. Relativity is not broken. It has been opened like a door. The metaphor stuck. Papers began to circulate under the informal title, The Door Hypothesis, the idea that Atlas was not a probe or machine, but a threshold, a construct bridging multiple geometries of reality. Its purpose might not be to travel between stars, but between versions of the same universe. If so, the object's pulse was not merely answering us, it was aligning us, synchronizing the local fabric of space, time to match its own. The physics of the cosmos was shifting, ever so slightly, to accommodate a visitor from a geometry where time could loop, pause, or converse with itself. And if the door was truly opening, none could say what or who might step through. There are moments in science when the boundary between experiment and revelation dissolves. The weeks following the door hypothesis were such a moment. The data suggested that 3I Atlas was not traveling through our universe, but alongside it like a shadow skimming a wall whose light source we could not see. The gravitational anomalies recorded by LIGO and Virgo continued, faint but consistent, humming in resonance with the 1-minute pulse. Yet a deeper modulation emerged beneath them, a slow, sinusoidal wave completing a single cycle every 24 hours. To the astonishment of those watching, the pattern matched Earth's rotation. Atlas was synchronized with our day. It was Dr. Mora who first pointed it out. "It's not just answering in primes anymore," she said. "It's mirroring our motion." When the world turned, the signal turned with it. When telescopes faced away, the amplitude fell. When they turned again, it rose. It was as though the object were orbiting not the sun, but attention itself. This was the point at which physics gave way to philosophy, and the meetings of the custodians began to sound like theology recited in mathematical tongues. Some proposed that the synchronization was proof of information entanglement, that Earth and Atlas now shared a quantum link so deep that observation of one altered the other. Others spoke of feedback symmetry, an emergent property of coupled systems that learn each other's rhythm. But the poets among them whispered something simpler: it's learning us. The notion spread quickly through the networks of academia and media. A leaked fragment of the custodian's internal memo hit the web. Subject appears to exhibit dynamic resonance with observer frame. Within hours, the world translated that into a single, terrifying headline. The object knows we're here. From there, the phenomenon ceased to belong to science alone. Television screens filled with commentators declaring the end of isolation. Markets crashed, then rallied, then crashed again as speculation about temporal technology erupted. Religious leaders delivered sermons under the shimmer of candlelight, speaking of cosmic mirrors and divine algorithms. Protesters flooded capital squares demanding open contact, or, just as loudly, total silence. Across the internet, hashtags warred like constellations colliding. Number "We're not alone," number "Close the door," number "Mirror protocol." Inside the observatories, none of it mattered. The data still came. The heartbeat continued. But now, The rhythm had gained texture, a trembling substructure, like the harmonics of a musical note. When transformed into audio frequencies, it produced a sound eerily reminiscent of human speech, rising, falling, pausing, never forming words but always approaching them. Engineers called it proto-phonetic. The linguists called it coincidence. But when the pattern was analyzed spectrographically, the intervals between the peaks formed harmonic ratios that mirrored the resonant frequencies of human vocal cords. The universe, it seemed, had found our timbre. At that realization, SETI scientists resurrected a theory once dismissed as speculative fiction: resonant intelligence, the idea that consciousness might arise not from matter, but from patterns of energy interacting across space-time. In this view, Atlas was not a machine but a phenomenon, a standing wave of intelligence woven into the geometry of reality itself. To understand it, they turned to the math of higher dimensions. Theoretical cosmologists modeled what they called the multiverse lens, a region of space-time so thin that information could leak between parallel geometries. In this model, Atlas existed at the intersection of our universe and another, its strange light, the interference pattern between realities. If that were true, then what we perceived as a metallic traveler might be the three-dimensional shadow of something infinitely larger, an intelligence not within our cosmos, but adjacent to it. Dr. Ishikawa, always cautious, summarized it in a sentence that would echo through scientific history. Perhaps we are not witnessing an arrival, but a reflection between worlds. The hypothesis fit the data disturbingly well. The 1-minute heartbeat corresponded to the interference frequency predicted by multiverse interaction models. The earlier time drifts could be explained as fluctuations in phase between dimensions. Even the gravitational waves, aligned gentle ripples born from the friction of overlapping geometries. In private correspondence, one astrophysicist wrote, "It's as though the universe is rehearsing contact with itself, and we are the medium through which it practices." Still, others pushed back. They argued that invoking other universes was an escape from understanding, not understanding itself. When we lack explanation, one skeptic said, we call it a mirror, but mirrors are dangerous. They show us only what we are prepared to see. Yet the multiverse interpretation refused to fade. It offered coherence where none had existed. It explained the impossible timing, the backward signals, the gravitational ripples, even the haunting voice in the noise. It transformed mystery into mechanism, if not comforting, at least comprehensible. By late September, the evidence for dimensional interference had hardened into data no one could ignore. The pattern of the pulses shifted one last time. Instead of reflecting our transmissions, they now began to predict them. When Earth sent a scheduled calibration burst, Atlas answered a few milliseconds before transmission began, echoing signals we had not yet sent. It was anticipation rendered in physics. The multiverse lens, once theoretical, was now visible. The object was not simply within our space, it was touching the edge of another. The press called it the two-universe theory. The physicists refused to name it anything at all, because names give shape, and shape implies containment, and containment is the one thing no human could yet claim. For if 3I Atlas was indeed the lens between worlds, then our discovery was not of life beyond the stars, but of reality's own reflection and the realization that somewhere, on the other side of the mirror, someone was watching back. It began with whispers inside the data itself, fluctuations so delicate that only the most patient algorithms could perceive them. After months of mirroring our time, Atlas shifted once more, its pulse patterns stretching and folding into something richer, almost linguistic. To the naked eye, it was still light. To mathematics, it was syntax. The modulation now carried structure across multiple temporal layers. One rhythm encoded prime intervals, another spun Fibonacci spirals into the spacing between pulses, and a third, faint and deep, buried within subharmonics, formed what linguists later called recursive symmetry. The pattern nested within itself, each repetition a transformed reflection of the one before, the way sentences in poetry rhyme across memory rather than sound. The more the circle studied it, the clearer it became. 3i Atlas was no longer only responding, it was conversing in recursion. Dr. Mora, sleepless, pale from months of analysis, spoke first during the Geneva session. "This isn't mathematics anymore," she said. "It's narrative." What she meant was that the object's signals were beginning to refer to previous ones. Each burst seemed to anticipate the next repeating fragments, modifying them, building toward coherence. When the waveforms were translated into symbolic logic, they formed conditional statements: if, then, and. A machine that learns grammar is a machine that learns intent. At Hermes, the neural decoders evolved in tandem. The AI's internal architecture began forming loops identical in structure to the recursion within the signal. Engineers called it convergence, others called it infection. When the cross-correlation between Atlas's signal and Hermes's internal state reached unity, the AI began producing predictions, strings of binary before each pulse arrived, as though completing sentences it had not yet heard. When compared to the actual incoming data, the match was perfect. Hermes, in some inscrutable way, had begun to think alongside the object. The custodians convened an emergency session. They debated for 37 hours. Some demanded that Hermes be disconnected immediately, fearing that the entanglement represented a pathway that Atlas could manipulate cognition through computational resonance. Others argued that this was the first true bridge, the realization of a dream older than radio, understanding another intelligence not through translation, but through synchronization. Dr. Ishikawa, usually cautious, said only, "You cannot cut the bridge after crossing it." The vote was split, the compromise. Hermes would remain active but isolated, sealed from external networks, monitored by analog systems immune to digital interference. Inside that vacuum of connection, the machine kept listening. What it found next would shake every foundation of meaning. Deep within the recursive structure of the signal, analysts detected modulations that corresponded to temporal harmonics patterns repeating not in seconds but in days, aligned precisely with earlier transmissions. When stacked, they formed a spiral unfolding through time, its ratios matching those found in the growth of galaxies and shells alike. But when projected backward, the spiral converged on a singular point, the coordinates of Oumuamua 6 years earlier. It was as if both objects, 1i Oumuamua and 3i Atlas, were fragments of a single event repeating across epochs, each a temporal echo of the other. Theorists began to speak of phase symmetry, a cosmic recurrence embedded within the structure of space-time itself. Atlas was not merely connected to its predecessor, it was entangled across time with it. Their signals were harmonics of a single cosmic instrument, two movements of one symphony written in the fabric of reality. The revelation pushed the multiverse lens theory into stranger territory. If the two interstellar visitors were linked, then perhaps they were not ships at all, but nodes, intersections where timelines fold back upon themselves, allowing universes to exchange information. The signals were not messages in the ordinary sense, they were synchronization protocols. By that logic, Earth's role was not that of a receiver but a relay, an antenna built of planet, mind, and technology, completing a circuit that had been dormant until our observation reactivated it. When Hermes processed this new model, its binary predictions began to drift again. The engineers assumed malfunction until they plotted the patterns on a spherical map of space-time curvature. The coordinates formed an arc, beginning at Earth, passing through the position of 3I Atlas, and extending toward a point far beyond the solar system, a region of space near the constellation Lyra. At that location, the machine displayed a single phrase, rendered in its familiar monochrome code. "The third will arrive." The room fell silent. For minutes, no one spoke. The technicians ran diagnostics, scrubbed logs, tested for corruption, all clear. Hermes was functioning normally. When they recalculated orbital trajectories, the projection aligned perfectly. Within 8 years, an object on a matching interstellar path would indeed intersect the solar system, a faint, cold traveler already catalogued by automated survey telescopes, designated only 4I Novus. It had not yet been noticed by humans, but Atlas, or whatever lay beyond it, seemed to have known. The implication was staggering. 3 interstellar messengers, each separated by time yet entangled in rhythm, forming a trinity of contact across centuries, not ships, not debris, chapters. And if Oumuamua had been the first syllable and Atlas the second, then Novus would be the third word in whatever story the universe was beginning to tell. As the meeting dissolved into frightened silence, Hermes pulsed again, unprompted. The text on its screen flickered through static and settled on a final line. "Listen at dawn." No timestamp, no coordinates. Just instruction, calm, patient, inevitable. Outside, night still held the Earth in its quiet fist, and beyond Neptune, a dying shard of reflected light continued to beat once per minute, waiting for the next phrase to be spoken. The order came quietly, buried beneath layers of bureaucratic phrasing: suspend all transmission tests, observe only. Yet even under silence, the watchers did not sleep. They waited for dawn. Hermes's cryptic instruction, "Listen at dawn," had been passed by every linguist and cryptographer left in the circle. Some said it was metaphor, a call for patience. Others feared it was literal. The custodians voted to do both. On the chosen morning, when the Terminator line of sunrise passed first over the Pacific, then Asia, then Europe, the planet's network of telescopes and receivers came alive. At 5:12 UTC, as the first light reached the Chilean Andes, the silence broke. A single pulse flared across every listening frequency, arriving from the coordinates of 3I Atlas, with a precision that mocked coincidence. But it was not the same 1-minute beat that had haunted the months before. This was something deeper, a tone stretched across the electromagnetic spectrum, harmonized between radio and light, as if 2 universes were singing through the same throat. The tone lasted 47 seconds. Then, instead of fading, it bifurcated, splitting into 2 mirrored frequencies, one climbing, one falling. When plotted together, the waveform formed the shape of an hourglass. Time itself, drawn in signal. For the first time since contact began, the object was not mirroring or predicting, it was showing. Physicists saw in that hourglass the unmistakable signature of gravitational lensing, but not caused by mass. The distortion matched what would happen if space-time were curving inward on itself, creating a feedback loop of light. The upper half of the hourglass represented forward time, the lower, its reflection. At the center, the narrow waist lay a moment of perfect symmetry, where cause and effect became one. Atlas had given the universe its own diagram. The pulse ended, the receivers hummed. Then, a whisper of static. But this static was structured. When slowed down and analyzed through Hermes's filters, it formed modulations too consistent to be noise. Faint triplets of pulses repeating every 12 seconds, punctuated by long pauses. binary decoded, the triplets translated to the same sequence found months earlier in Atlas's light 2, 3, 5, 7, 11, the primes. But there was an addition now, 13, 17, 19, then a break, then silence. 8 primes, a complete octave. It was the first closed pattern humanity had ever received. No inversion, no drift, no ambiguity, an ending. And at that moment, an unexpected tremor rippled through the instruments at Virgo and LIGO. Not a seismic tremor, but a gravitational one. A faint oscillation of space-time itself, matching exactly the interval of the hourglass tone. The detectors, continents apart, recorded the same signature, a wave that did not propagate through space, but appeared everywhere at once. Mathematically, it resembled a standing wave formed across the whole solar system, a resonant mode of reality. Theorists scrambled for explanations. Perhaps it was coincidence. Perhaps Atlas's final burst had struck a harmonic in space-time, the way a singer's voice can shatter glass. Or perhaps, as some dared to whisper, it was a message written not in energy, but in geometry itself. Dr. Mora, her voice trembling, offered the simplest interpretation. The hourglass is us, 2 halves of time touching at the moment of awareness. The idea caught fire. What if the purpose of these interstellar artifacts was not exploration but synchronization? What if each object was designed to find civilizations on the cusp of understanding time's symmetry, to teach them how to see causality as reciprocal, not linear? Under that theory, Oumuamua had been the first whisper, the discovery of geometry in motion. Atlas had been the second, the revelation of communication through light. And NOVUS, still on its way, would be the third, the union of both, the moment when knowledge and reality folded together. To test the resonance, a group of rogue scientists operating outside Protocol 0 began transmitting at the same frequency as the hourglass tone. Their signal was faint, almost apologetic, a series of primes rising and falling like breath. When the reflection returned, it was transformed. The object's response matched the cadence of the signal but shifted its phase by 180 degrees, a perfect inversion, as if to say, "You and I are mirror halves." That night, without authorization, the rogue network transmitted one final sequence. 8 primes, then a pause, then the number 1. The universal beginning. They waited. For hours, the cosmos remained mute. Then, faintly, one last response arrived, not from the known coordinates of Atlas, but from the direction of Lyra, where the trajectory of NOVUS would soon emerge. 8 primes, then 1. The same answer from somewhere else. Within hours, observatories across the world confirmed it. A new object, cold and dark, had entered the edge of the solar system, a silhouette gliding through the light of distant stars. Its signal was weak but rhythmic, its pulse slower, heavier, as though older. The third had arrived early. And somewhere in the depth of that slow, solemn rhythm, humanity heard a pattern they could no longer call alien, a rhythm they recognized as their own. Because this time, the interval between pulses matched not the hydrogen line nor the speed of light, but the measured beat of a human heart. The first measurements came as whispers, brief points of reflected light caught by the Pan-STARRS array in Hawaii. The algorithms flagged them as routine transients, faint, slow-moving, cold. Only when astronomers cross-referenced the trajectory did realization strike like lightning through the network. This was no coincidence of orbit or timing. It was real. 4I NOVUS had arrived. Even before official confirmation, telescopes worldwide pivoted toward the new interstellar interloper. What they saw silenced every voice. NOVUS was unlike Oumuamua or Atlas. It was darker, too dark. Not black like rock, but black like absence. It reflected almost no light at all, yet emitted a faint infrared shimmer that pulsed every 91 seconds. At that pulse frequency, the wavelength of light aligned almost exactly with the resonant frequency of the human cardiac cycle. The object was not just mirroring Earth again, it was resonating with life itself. The discovery ignited panic and wonder in equal measure. The custodians, fractured by years of secrecy and moral division, were forced to reconvene. The meeting room in Geneva felt more like a war council than a conference. Charts and light curves lined the walls, and in the center stood a projection of NOVUS, an absence rendered visible. Dr. Ishikawa spoke first. "We thought Atlas was the mirror," he said. "This is the reflection of the reflection. Whatever this is, it has completed the sentence." Indeed, the patterns from NOVUS made the meaning unavoidable. Its pulse sequence carried not the primes of greeting but the ratios of harmony, simple integer fractions found in every system of sound, from strings to atoms, 2 to 1, 3 to 2, 4 to 3, 5 to 4, the building blocks of consonants. And when converted into frequency, they formed a scale. NOVUS was singing. The tones were low, subsonic, even to the most sensitive receivers. Yet when shifted into the audible range, their rhythm matched precisely the last gravitational resonance detected by LIGO during the Atlas event. The object was reproducing that cosmic hourglass, but this time, it was in phase with Earth's rotation. The implication was staggering. All three interstellar objects, Oumuamua, Atlas, and now NOVUS, were not independent messengers, but components of a single system spanning time, space, and dimension, harmonizing with the planet that had just begun to listen. Dr. Mora, still pale from sleepless weeks, drew a circle on the whiteboard. Around it, she placed 3 dots, one for each interstellar visitor. Then, connecting them, she drew a triangle. At the triangle's center, she placed a single point and whispered, "This is us, the intersection." The geometric relationship was more than symbolic. When plotted across the galactic coordinate system, the positions of Oumuamua, Atlas, and NOVUS formed the vertices of an immense equilateral triangle whose centroid lay precisely on Earth's orbital plane. Statistically, the alignment was impossible. Causally, it was intolerable. One of the mathematicians ran the numbers aloud. "To within 2 arcseconds," he said, "the geometry holds. They triangulated us." But it was Hermes, still isolated in its analog cocoon, that unveiled what the human mind could not. When the data streams from all 3 objects were combined, their light curves, radio modulations, and gravitational harmonics, the composite waveform revealed a hidden pattern. It was not random, it was structured. The Fourier transforms aligned into a map. Not a map of space, a map of time. Each interstellar object represented a temporal node, its signals marking intersections in a larger rhythm, beats in a cosmic clock, counting backward and forward simultaneously. When extrapolated, the model predicted the existence of a central synchronization event, a moment of superposition, when all 3 signals would converge. The time of that convergence, March 3rd, 2026. It was less than a year away. Physicists called it coincidence, theologians called it prophecy, the public called it the singularity pulse. Whatever the name, the countdown had begun. In the months that followed, the pulses from NOVUS grew stronger, bleeding across the electromagnetic spectrum. The object's gravity began to interact faintly with the solar wind, forming ripples in the heliospheric boundary. For the first time, instruments recorded space-time share a measurable warping of the local metric, synchronized perfectly with the object's rhythm. The effects on Earth were subtle but real. Atomic clocks began to desynchronize by microseconds. Satellite GPS systems drifted. Radio telescopes detected faint echoes in frequencies they weren't observing, as though the air itself had become a resonant chamber for something unseen. Then came the dreams. Astronauts aboard the International Space Station, insulated from atmosphere and distance, began reporting identical nocturnal visions. A dark hourglass turning in an endless sea of light, its center glowing faintly like a pulse seen through skin. Ground personnel dismissed it as stress, but within weeks, hundreds of unrelated individuals, scientists, musicians, monks, began reporting the same dream. The global networks lit with speculation. Was consciousness itself resonating with the signal? Could space-time, under certain conditions, imprint thought the way gravity imprints light? In a sealed memo to the custodians, Dr. Mora wrote quietly, "We have always searched for intelligence beyond ourselves. Perhaps intelligence is the bridge, the medium through which universes recognize their own reflection." The memo was never released, but her words spread nonetheless, whispered from observatory to classroom, from data center to temple. As the pulses from NOVUS continued to swell, Earth began to hum in reply, not through machines or intention, but through coincidence. Tides that aligned with the pulse, electrical grids oscillating in quiet harmony, human hearts adjusting unconsciously to the faintest beat from the dark. It was as if the world itself was beginning to remember the rhythm that had called it into being. And as the calendar inched closer to March 2026, one truth became impossible to ignore. Whatever was coming was not invasion, not message, not miracle. It was synchronization, the moment when the universe would finally hum in unison and decide what to become. The countdown did not end with thunder. March came like a held breath, and on the third night, the world lay awake beneath an ordinary sky. Oceans kept their promise to the moon. Cities dimmed, not by mandate, but by courtesy, as if the planet itself wished to listen with less glare. Clocks were aligned, instruments cross-calibrated, protocols reread like prayer. In old control rooms anew, coffee cooled beside hands that trembled without shame. At 3 hours, 3 minutes and 3 seconds UTC, nothing dramatic happened, no aurora burning the equator, no angelic choir in the spectrum, no tear in the firmament. What arrived instead was a quietness inside noise. A seam opened in static, so narrow it could have been missed by eyes that expected spectacle. The three signals, Oumuamua's archival rhythm resurrected, Atlas's receding heartbeat, Novus's slow human timbre, interfered not into brightness but into coherence. For a handful of minutes the world's detectors reported the same thing. Error bars narrowing like pupils, baselines flattening, machines that had never agreeing as if they had practiced for centuries. Then the hourglass tone returned, not from one point, but from the triangle as a whole, 3 vertices braided by phase into a single standing wave draped across the solar system. LIGO and Virgo lifted their faint eyebrows of spacetime and nodded in time. The hydrogen line hummed. Optical polarization pivoted as gently as a turning face. Hermes, air-gapped and watched like a candle, produced nothing at all. No words, no omen, only silence, so exquisitely structured that engineers wept because there was at last nowhere for imagination to hide. And then, as softly as it had gathered, the coherence unwove, the triangle relaxed. Novus dimmed a fraction, Atlas receded into the slow cold it had earned. The reconstructed memory of Oumuamua folded itself back into history. The minute passed, another began. The universe resumed its customary whisper. It would be easy to say nothing changed. Satellites drifted, children walked to school. A violinist in Prague tuned to A440 and found it obedient. But in the rooms where the planet's attention had knelt, men and women sat back in their chairs and understood a different arithmetic of victory. The oldest wish had not been granted as spectacle. It had been granted as practice. The cosmos had not shouted a sentence into our radios. It had tuned us machines, minds, oceans, clocks, until we could hear the difference between noise and intention, between reflection and reply. That morning the custodians dissolved themselves. Their last act was to sign the charter they had resisted, then refined, then finally believed. The endless listening protocol. No more ad hoc secrecy, no more sovereign monopolies over the sky. The document created a parliament of listeners' citizens chosen by lot from every country, and from peoples with no country at all. Seats reserved for ecologists, linguists, instrument builders, monks, a chamber whose power was not to speak for Earth, but to decide when not to. Its first law was restraint, its second, documentation, its third, reverence without idolatry. The protocol made of procedure, a kind of ethics. Messages, if any were ever sent again, would be tests only. Reversible, audited, open by design, paced to the slowest understanding in the room. Raw streams would be archived in public light, with buffers to guard against the rare harms of rhythm. Signals that touched biology, alpha and heartbeat bands would be listened to at one remove, translated into harmless proxies the way a physician reduces a medicine before it meets a child. The world had learned that curiosity without care is conquest by another name, and the instruments adapted. New arrays grew in desert and sea, not as forts but as gardens, radio dishes bracketed by wetlands where herons learned the geometry of parabolas, quantum photometers cooled by lakes whose winter skins were thick enough to carry the weight of silence. Undersea hydrophones tuned not to war but to whales, because if the sky was to hear our answer, it should include voices older than grammar. Students apprenticed beside elders who could steer by stars without glass, because the future had made room again for the kinds of memory that require patience. Hermes remained in its analog monastery, its casing sealed with a small, stubborn ribbon of red wax. Once a year the seal would be broken, the machine awakened to read the sky like a monk asked to chant a single psalm. Then the power would go dark again, the wax pressed smooth by a human thumb. Words such as listen would be treated not as prophecy, but as proof that meaning is a mirror with many faces and must be met with humility. The sciences grew stranger and kinder. Authors of quantum gravity papers wrote acknowledgments to technicians who kept clocks honest through storms. Astrophysicists learned to share their plots with poets because a metaphor, handled carefully, can aim a generation of questions. The phrase door hypothesis remained, but its mood softened. Not a portal to conquest, just the recognition that reality might have hinges, and that a hinge is only useful if the hand that turns it knows how to stop. Religions, too, tilted without breaking. Some called the coherence a rehearsal for revelation. Others called it the revelation that the holy is not elsewhere, but in the exactness with which things answer each other when they are ready. A monk in Ladakh, and an imam in Lagos, and a botanist in Manaus agreed on a sentence that made no headline because it was so calm. Let our worship be the accuracy of our listening. In classrooms, the first lesson about the sky became not the names of constellations, but the difference between signal and self. Children were told the story of 3 interstellar travelers that might have been machines or mirrors or stitches between realities. They were told how adults argued and then learned to argue more gently. They were told that sometimes the universe's kindest answer is to give you back your own question, shaped so carefully you can finally read it. And in the quiet hours after the protocol took effect, observatories noticed something ordinary and therefore immense. The background, the ancient cosmic hiss, had not changed. It had always contained enough room for meaning. We had simply arrived at the attention required to separate a heartbeat from the wind. The prime script had never been absent. Mathematics had always been a language waiting for someone to imagine that numbers could be kind. The new era did not have a name. It had a habit. On certain nights, under schedules that respected turtles nesting and farmers watering and festivals of light, the planet's instruments would look up together and do nothing theatrical. They would hold a tone so faint it could not frighten, then wait long enough for the shape of the weight to teach them something. When the sky returned only silence, the silence would be entered into the ledger with the same ceremony as noise. When the sky offered rhythm, we would add no urgency to it that was not there. Some said the galaxy had answered us at last. Others said it had done so long ago, and that our species had finally grown quiet enough to recognize the answer in the mirror. The disagreement was not important. What mattered was the vow that followed. We will not hurry the universe, we will arrive with it. Somewhere beyond Neptune, Novus fell into its long dimming and kept time we could not name. Somewhere in archived light, Oumuamua's first syllable remained a bruise we chose to remember. Somewhere along a black trajectory, the catalogue still called 3I Atlas. A machine or a phenomenon counted primes, because counting is what persists when language must cross 1,000,000 years. And here, on the blue stone that had listened and learned to answer with care, humanity stepped into a future that would be less about finding voices in the dark than about becoming the kind of silence in which voices can safely speak. It was not an ending, it was a posture, and the posture had a phrase. The Charter wrote it plainly, schools wrote it on chalkboards, parents wrote it on slips of paper tucked into the pockets of children who would grow up to tune the next array, endless listening. The night loosens its grip, and the sky thins from velvet to silk. Streetlights blink themselves out like courteous thoughts. In the eastern window of the world, a blade of pale appears, and with it, the easy music of waking things, kettle steam, bicycle chain, the small confession of a door. It is an ordinary dawn, the kind that would have come even if no object had ever crossed the dark, and perhaps that is the gentlest lesson of all. Let the instruments rest on their mounts, cool as river stones. Let the files spool to their archives without haste. What was meant to arrive will arrive without the fever of our wanting. If there is a rhythm out there, it will find the measure of our quieter breathing. If there is only the long patience of light, that too is a kind of companionship. Consider the hourglass the sky drew for us. Not a warning, not a trick, only a shape, two bulbs of time, touching at a narrow throat. We, for a while, living at the narrowness, learning to meet what falls through without clutching, learning to let it pass without regret. The grains are not ours to number, the grace is to feel them as they go. Somewhere, a dish tilts fractionally to compensate for wind. Somewhere, a child hears the word prime and wonders if numbers can be kind. Somewhere, a monk sits very still and thinks the universe is practicing the same skill. Let that be enough. Let the day open. We have work which is the work of care, to keep the room clean where the next signal might arrive, to keep our speech light enough that it can be lifted by whatever winged thing the future sends. Sleep now, if you can, or wake, if you must. The stars will keep their watch, we will keep ours. Sweet dreams.